Okay, welcome to this video where we're going to be having a look through a load of questions which are very common topics that appear on paper 1. Now when you look through the checklist, it's not that you can go through the checklist and just tick things off and say they don't come up on paper 1. Any of these topics can appear on a paper 1 exam. For example, something that you might think is a calculator topic could be something like circles, but these can be written in terms of pi. So really, when you go through this checklist, there's nothing which you can cross off and say that's definitely coming up on a calculator paper, which does make the paper 1 exam the nastiest one in my opinion, because you do have to revise everything. So we're going to go through a load of questions where you can just sit and you can do your revision with me the day before the exam, making sure that we practice a lot of common topics that appear on paper 1. Now we've got a lot to get through and not enough time with the exam coming up tomorrow, so we are going to get started straight away. So good luck, stick with me, and if you don't make it to the end, which I'm hoping you do, best of luck in your exam. Okay, so we're going to round these numbers to one significant figure. So 6.32 is going to round to 6, 6.51 rounds to 7, and then 0.503 to one significant figure on the bottom is 0.5. Now whenever we've got these, we've got to work out what's on the top and what's on the bottom. So on the top there, 6 times 7 is 42, and it's 42 divided by 0.5. Obviously if that was a nice little division there, we could do that straight away, but dividing by a half does something in particular. So dividing by half actually doubles your answer. If you think half fits into 1 twice, so it'll fit into 42 84 times. So there we go, dividing by 0.5 doubles our number. Obviously if we had something like 3 on the bottom or something like that, that'd be a little easier, but dividing by 0.5 doubles our answer. So that's estimating. Just remember to round to one significant figure and then to complete your sums that way whenever you see that word estimate. So write 180 as a product of prime factors and give your answer in index form. So we can do our nice little prime factor tree. And again, thinking of any two numbers that times to make 180. So I'm going to go for 18 and 10. 10 becomes 2 and 5, locking off those numbers when we see that they're prime. 18 is 2 and 9, and 9 is 3 and 3. And again, locking those all off when they're prime. Remembering you can write down some of the prime numbers if it helps. Now writing these in size order, we get 2 times 2 times 3 times 3 times 5, and then we can simplify these. So 2 times 2 becomes 2 squared, 3 times 3 becomes times 3 squared, and then times 5 at the end, and that's in index form there using index. Right, so a washing machine costs £640 plus 20% VAT. James pays a £68 deposit and the rest in 10 equal monthly instalments. Work out the cost of each monthly payment. So it's a percentage of an amount question, so we need to work out 20% of 640. 10% is the most important percentage we ever have to work out, so we can work out everything from there. So we'll work out 10%, 10% is £64. 20% will be double that. So double that is £128, so that's the extra amount he's got to pay for VAT. So if we add these together, 640, add 128, we get £768. Now it says he's going to pay a £68 deposit, so let's take that £68 off because that's what he pays right at the start, and that leaves us with £700. Now it says in the question he's going to pay that in 10 equal monthly instalments. So if we finish this off, if we divide this by 10, so 700 divided by 10 tells us that he's going to pay £70 per month. There you go. So the main part here was the working out the percentage. So always work out 10%, and remember from there you can figure out any percentage. We could have halved 10%, we could have got 5% as 32, or we could have actually divided it by 10, we could have got 1%, dividing 64 by 10, 1% would have been £6.40, and we could have built that up to any percentage that we wanted from there, so £6.40. Let's have a look at something else. Okay, moving on to fractions, multiplying and dividing fractions. Multiplying fractions is the easiest one, isn't it? So we can times the top numbers, 3 times 2 is 6, and times the bottom numbers, 4 times 3 is 12. And we always want to simplify our answer, and a question will normally ask us to write it in its simplest form. So here we can divide the top and bottom by 6. And we get 1 over 2 as our final answer there. So always looking to simplify. On to the next one. We keep the first fraction the same. We flip the second one over and we multiply them together. So times in the top numbers just like before. 2 times 5 is 10. 1 times 9 is 9, and again we'd normally be asked to write our answer in its simplest form or as a mixed number, and here it is an improper fraction. 9 fits into 10 once, with a remainder of 1/9 left over, so 1 and 1/9 would be my final answer there, and that's dividing fractions. When it comes to adding and subtracting, the process is the same. I'm just going to go for this one addition. So when we're doing this, we need to obviously look at the fact that there is a mixed number here, and we're going to make that into an improper fraction first, and the same goes for multiplying and dividing. So we're going to do 1 times the 4, the big number times the bottom, and then add the top. So 1 times 4, add the 3 is 7/4. And we're going to add to that this 2/3, and again if that was a mixed number we'd also convert that into an improper fraction. Now we need a common denominator when we're adding and subtracting, so that's going to be 12 on the bottom, so we can times this left fraction top and bottom by 3, and we can times this right fraction on the top and bottom by 4, and that's going to give us 2 fractions out of 12, so 7 on the left times 3 is 21/12, and on the right 2 times 4 is 8/12. And now we can add these together, and again if we were subtracting them we'd just subtract those numerators now, but we'll add them together and we get 29/12. And again it says to give your answer as a mixed number, so we are going to convert this now into a mixed number. 12 fits into 29 twice up to 24, and there'll be a remainder of 5/12. And again, there's my final answer. Just be very, very careful at this point, just to have a look. Does this fraction simplify here, the little one? It doesn't, but let's imagine it was 4/12 there instead of 5/12. That would actually simplify, wouldn't it? Because if it was 4/12, we could divide the top and bottom by 4, and that would end up being 1/3. So just have a look in that situation. Does it simplify? This one obviously doesn't. It's 2 5/12. Let's have a look at another one. So in a bag of counters, 2/5 are blue, and it says 18 are blue. Work out the total number of counters in the bag. So it's not asking us to work out 2/5 of a number, it's saying that 2/5 are 18. Remember, it could have said work out 2/5 of, let's say, 20, and you divide by the bottom to get 1/5, you'd say that 1/5 is 4, and then times by the top to get 2/5, and we'd get 2/5 would be 8. That's a different question, so it's nothing to do with that, but it says 2/5 are blue and 18 are blue, so 2/5 equals 18. So if I want to work out 1/5 in this scenario, I need to divide by the top this time, because that gives me 1/5, half of that. So 1/5 would be 9, and then to work out 5/5, the original amount, we could times that by 5. So times it by 5, and we would get 5/5 equaling 45 counters. There you go, so that's our scenario there. So slightly different the other way around, obviously, to working out a fraction of an amount. It says that that fraction is 18. So dividing it by 2 to get 1/5, and then timesing it by 5 to get the original amount. Okay, so writing some numbers in standard form. We're going to make this a number between 1 and 10, times 10 to the power of however many jumps we have to do in whatever particular direction. So this number here, 5,600, I'm going to hop the decimal in between the 5 and the 6. So 1, 2, 3. So that becomes 5.6 times 10 to the power of, it's a big number there, it's not a 0-point number, so 10 to the power of 3. Final answer. The next one is a small number, so we're going to have a negative power, because we hop the decimal the other way this time, so 1, 2, 3 would make it 3.4, and again this time it would be times 10 to the negative 3, because it's a 0-point number, that indicates that it's a small number. When it comes to the other way around, writing them as ordinary numbers, I like to rewrite this little bit at the start to start with. So 2 and 3, and I like to just imagine where that decimal is between the 2 and the 3. So times 10 to the power of 5 makes it a big number, so we need to hop it 5 places. 1, 2, 3, 4, 5 to the right, and then filling in all those zeros underneath. And if it is messy, just remember to rewrite that, but there's my answer, 230,000. The next one, 8.04 times 10 to the negative 3. So this is going to be a 0-point number, and again I'm just going to write these digits out at the start, these bits here, and imagine where the decimal is at the top, 8.04. So negative 3 means it's going to be a small number, so we're going to jump it left 3, 1, 1, 2, 3. So it's going to go there, fill in all the zeros, and tidy it up at the start. So 0.00804, final answer. Okay, so looking at this one, 4 times 10 to the 5 times 3 times 10 to the minus 2. And there's an example of one where we probably wouldn't want to write this out as ordinary numbers and work them out, because it might get a little bit overcomplicated here. But let's look at applying that same little trick. So let's do the 4 times the 3, which gives us 12. And that's going to be times 10 to the power of something. I'm just going to be a little bit careful here, because although we can add these powers, let's just have a look, because one of them's a negative. So the powers, if I write this to the side, we're going to do 5, the first power, and we're going to add the next power, which is negative 2. And 5 plus negative 2 is 5 take away 2. So my power there is going to be 3. So that's fine, 12 times 10 to the power of 3. And again, we just need to put this in standard form because this 12 is not between 1 and 10. So instead we'll make that one jump smaller, we'll make it 1.2. And to balance that out, we'll make the power one jump bigger, so 3 goes up to 4. And there's our final answer, 1.2 times 10 to the 4. Same process again. We've got 3 divided by 6 though. So let's do this to the side. 3 divided by 6, let's write that as a fraction. 3 divided by 6, if we simplify that, goes down to 1/2. So to keep this as a number rather than a fraction, I'm going to write that as 0.5. So over here we have 0.5 of 3 divided by 6. And then we've got that times 10 to the power of, and again, subtracting the powers on these. So we've got 3 take away and negative 2 on the second one, and 3 take away negative 2 turns into a plus. So we have 3 plus 2, which gives us a power of 5 for this one. So we have 0.5 times 10 to the power of 5. And again, we can balance this out because it needs to be in standard form, but this time, to make 0.5 between 1 and 10, we make it one place value bigger, to make it 5. And if we make the number bigger, the opposite this time for the power, we make the power smaller. So 5 drops down to a 4. So 5 times 10 to the 4. So a similar process, but here we had to make the number bigger, so we made the power smaller. Okay, so this question here, we have got it in reverse. So it says write 35% as a decimal. So again, I'm going to write the percentage. I'm going to write it without the percent sign and just write the numbers 35. So to turn it back into a decimal, we just divide it by 100. So we hop the decimal back in 2 places, which would make it 0.35. Obviously, when we're writing a decimal though, if we have a decimal point at the start there, we do want to just tidy that up and put a 0 at the start, so it's 0.35. And there we go, that's writing it as a decimal. So very similar to our previous question. Now we want to write it as a fraction. It says write 35% as a fraction. Now of course this has already given it to us as 35%, so we can straight away put that as 35 per 100, or as a fraction 35 out of 100. And again, that is all we need to do in terms of writing it as a fraction. Again, this question though does say give your answer in its simplest form, so we need to spot what they both divide by. Now hopefully you can see that because one ends in a 5 and one ends in a 0, that they definitely both divide by 5. So we'll divide them by 5 to start with, and then we can always see if it divides any smaller. So 35 divided by 5 is 7. In fact, let's just swap back to our other colour there. 35 divided by 5 is 7, and 100 divided by 5, don't know why I put divided by 2 down there. We definitely wanted to divide by 5, but 100 divided by 5 is equal to 20. So we've got the answer 7 over 20. Again, the numerator there, 7 only divides by 1 or 7, and 20 doesn't divide by 7. Not perfectly anyway, and we are looking for a number that fits in perfectly. So our answers there was 0.35 for our decimal, and 7 over 20 as our simplified fraction. Okay, so it says here, write the following numbers in ascending order. Now ascending order means smallest to biggest. So we need to find out which of these is the smallest, which is the biggest, and put them in order. Of course, at the moment we have a decimal, we have a fraction, we have a percentage, another fraction, and another decimal. So it's not very nice to order them as they look. So the best thing to do on a question like this is to turn them all into the same format. Now, you might have noticed on the previous questions, but with all of them we used percentages. So personal preference for me, I like to write them all as a percentage. So first of all, why don't we just try converting them all into a percentage? Of course you could try something else here, but I do think the percentages are the much easier way in order to do this. So for the first one, 0.30, and of course don't forget you can put a 0 at the end there, because then when we multiply that by 100 it gives us 30%. So our first one is 30%. For the second one, we want to turn that into a fraction over 100. Of course, if you just know this already, then that is fine, but 1 over 4 would become 25 over 100. So that one there is 25%. Of course, if you just know that, that's fine as well. You don't have to show the working out for that as long as you're confident with it. Now the third one is already written as a percentage, so that's nice and easy, 28%. The next one's a fraction. So again, let's think about how we would turn that into a percentage. 6 over 25, we would want to multiply the top and bottom by 4 to make it over 100, and 6 times 4 is 24. So that becomes 24%. And then for our final question here, or our final part of this question, we've got a decimal. So if we times that by 100 and we hop the decimal, it's going to jump over the 9. So that is going to become 29.5. And there's our first part where we've had a decimal inside our percentage. But that's fine as well, it's just 29.5%. So let's get rid of our working out and then let's think about which one of these is the smallest, and then we'll put them in order. Now when you're doing this question, it says write the following numbers in order. It doesn't say to write these percentages in order. So we do have to write the original parts of the question in the appropriate order. But before we do that, I'm going to order them from the smallest. So hopefully you can spot 24% is our first smallest number. We then have 25%, which is our second. Then we have 28%. Then we have 30%. And then actually, I've missed out the 29.5. Our fourth smallest was definitely the 29.5%. And then we have our 30%. So as you've just seen, always be very careful and check that you've read all the numbers carefully. So now we've got that done, let's just write the original parts in order. So the first one was the 24%, and that was 6 over 25. The next one was the 25%, and that was 1 over 4. The next one was 28%, and that was already a percentage, so that's fine to leave it. The next one was the 29.5%, which is 0.295. And the final and biggest part was the 0.3. And there we go, we've written them all in ascending order using our conversions. Okay, so we're looking at some negative numbers. Now it says here at 7 AM the temperature was negative 4 degrees. It says by 3 PM the temperature had gone up by 10 degrees. Write down the temperature at 3 PM. So in order to do this, we're going to first bridge 0. So what I mean by that is, what do we have to add to negative 4 to get to 0? That's going to be 4, and then we've got an additional 6 to add on. So the calculation we're actually doing here is negative 4 add 10. You might be quite happy just doing that, but we've got to add 4 to get to 0, then an additional 6, and we do get to 6 degrees Celsius. So there we go, that would be our answer for that, 6 degrees. For the second part of this question, it says at 9 PM the temperature was negative 2 degrees, and by midnight the temperature had gone down by 7. So the calculation we're doing here is negative 2 as our starting position. We're going to take away 7 as it's going down by 7. So negative 2 take away 7 would get us down to negative 9 degrees, and that would be our final answer. So this is obviously just looking at adding and subtracting when we have negative numbers involved, not forgetting, and this is something that people tend to get wrong, just because there are 2 negatives in this question, that does not mean that it becomes a positive. That rule only applies when you have 2 negatives next to each other. So if I was to create a completely different question, I could have something like 3 take away negative 5. Now this is the scenario when they are right next to each other, whereby they turn into a plus. So that would become 3 plus 5, which equals 8. So this is the one scenario where it happens, and of course when you are multiplying with negatives, so something like negative 3 multiplied by negative 5 would become positive 15. So these are the scenarios where 2 negatives do end up or result in a positive answer, but it certainly doesn't apply when we have a negative number as our starting point and we are simply taking away. So obviously don't forget that when it comes to negative numbers. Obviously sidetrack from the question slightly there, but hopefully that's going to help us a little reminder when you're dealing with negatives. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided, so x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1, which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. So a equals 5b plus 2c, b equals 3 and y equals negative 2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket, so we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of negative 2. We put these in a bracket like that. All we have to do is now multiply these. So 5 times 3 is 15. 2 lots of negative 2 is negative 4, and we're adding these together. So 15 add negative 4 is 11, remembering that these just become a takeaway, so it's 15 take away 4. So a would equal 11. There you go. Just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. Okay, so on the number line, show this inequality. So when we're drawing these sorts of things on a number line, we look at what numbers we've got. We're going to put our little circles above those, so negative 2 and 4. And we're going to join them up. And then we just need to have a look at these symbols. So the 1 here, which is less than or equal to, or pointing towards that less than or equal to, it has more ink on it, so we just remember to colour that one in. Make sure the circle has more ink in there as well. Nice little way of remembering it. There we go. So that is between -2 and 4, remembering that is equal to -2. So the numbers that this could be is we could have -2, -1, 0, 1, 2, and 3, but not including the 4 there because it says less than 4. So you can have an inequality like this as well, where it just says x is greater than or equal to 1. So again, putting our circle above the 1, the greater than or equal to has the extra ink on it, so we'll colour that one in. It's equal to that as well, and greater than 1, so we'll just point an arrow to the right saying it's got to be greater than 1. And that's that for that type of inequality. Okay, so a nice quick one here, solving an inequality. Now this symbol shouldn't put you off here. It's an inequality, yes, but we're going to treat it exactly the same as if it was an equal sign. So before we saw a question like this where it was 2x plus 3 equals 20. We're going to do it in exactly the same way, but we're just going to leave that symbol in there. So we're going to take away 3 from both sides, which leaves us with 2x is less than 17, and then dividing by 2. We get x is less than 17 over 2, and we could probably work that out. 17 over 2, half of 17 is 8.5, so x is less than 8.5. Okay, so on to factorising a quadratic. This is the opposite of expanding a double bracket, so we know what our answer is going to look like already. It's going to be in a double bracket, both with an x at the start. Now when we're doing this, we've just got to find the pair of numbers that are going to go into our bracket. So looking at the 12, we know it's going to be a pair of numbers that multiply to make 12. So I always write these down. We can have 1 and 12, 2 and 6, or 3 and 4. Now we just need to have a look at these numbers there, because we've got a 7x in the middle, so they have to add up to make 7x. So 1 and 12, there's no way I can make 7. 2 and 6, I could either make 8 by adding them together, or I could make 4 or -4 if I do a minus with one of them. So I'm not going to make 7, but I can make it with 3 and 4. I can have +3 and +4, and that would make 7. So +3 and +4, and that's not a 4, +3 and +4, and that would be factorised. Having a look at the one below, we've got some negative symbols going on there, so we've got a slightly different process, but our answer is going to look the same. It's still going to be in a double bracket, it's still going to be x at the start, and we're still going to have 2 numbers in here with some symbols. So 28, the numbers at times to make 28 are 1 and 28, 2 and 14, or what else could we have? 4 and 7, and let's have a look if these can make 28. So what have we got? We've got -3 in the middle. So we want to make -3. Well, we're not going to do that with 1 and 28. That's not going to work. 2 and 14, we could make 16, or we could make 12. That's not going to work. But 4 and 7, we could do +4, take away 7, and that would make -3. So +4 and -7. And that's our double bracket there finished. So when it comes to solving a quadratic, the way to solve it is we have to factorise it. And we can only factorise it, and we'll discuss this a little bit more, when it is equal to 0. So sometimes they won't be equal to 0, but particularly in the foundation level style questions, they're always going to be equal to 0 here. And if they're not, we'll have a look at how to obviously just rearrange them slightly in a later question here. But when it comes to this here, all we're going to do is we're going to have a look at that quadratic there. So we've got x squared plus 7x plus 12. Now when we're factorising one of these, they go into a double bracket. And all we do need to do is have a look at this number at the end, which is 12, and we have a look at what numbers multiply to make 12. So we could have 1 and 12, and again, I'm not going to talk about this too much because I'm going to link the description for factorising quadratics, but we can have 6 and 2, and we can have 3 and 4. So we just need to figure out what combination of numbers are going to go into our double bracket. So we'll put our double bracket here, it's all equal to 0, and we've got an x at the start of both brackets. So obviously we're looking at that number in the middle there, the coefficient of x, which is positive 7. So the two numbers that have multiplied to make 12 and also add to make that positive 7 are our 3 and our 4. Okay, so we're going to put 3 and 4 in our bracket, and that would be plus 3 and plus 4. There we go. Now in terms of obviously our solutions here, now you don't really need to know this for this question in particular, but if this was a quadratic equation, a line equation, sorry, it would relate to a quadratic curve. Okay, now I'm going to draw what this would look like. It looks something like this. Okay, there we go, not to scale there, but it looks something like that. Now when we are looking at the solutions here, we are looking for essentially where this curve crosses through the x-axis, and that's what equal to 0 is representing there, and it's in a kind of very simple level. Equal to 0 kind of means a ground level. It means where y is equal to 0, and if you think about the y-axis, the y coordinate just here, we've got y equals 0 just down there. So we are having a look at, on this graph, where does the quadratic curve cross through the x-axis when y is equal to 0. Now there's a little trick with these brackets, but in terms of obviously explaining how we go about getting our solutions here, we just say, okay, well when does this bracket here, x plus 3 equal 0? And if we write that out, when does x plus 3 equal 0? And if we take away 3 from both sides to solve that, we get x has to be equal to negative 3. And if we do that for the other one as well, so if we do that for this one just here, we say, okay, well when does x plus 4 equal 0? And again, if we solve that and take away 4 from both sides, we get x has got to be equal to negative 4. So there we go. If I label that on the graph here, we've got minus 3 and we've got minus 4, and that's how I knew what the graph would look like. But there we go, there's our two solutions. X is negative 3 and x is negative 4. But if you have a look at the bits in the brackets there, obviously we've got a plus 3 in the bracket, and our solution ended up being negative 3. And on the flip side, on the other one, we had plus 4 in the bracket, and our solution ended up being negative 4. So obviously it's important to know how to do this little process here, setting them both equal to 0 and solving it for some of the harder ones. But in terms of just getting through these questions nice and quick, once you've factorised it, all you have to do is flip the symbol in the bracket there. And we're going to have a look at a couple of others where maybe there's a negative in the bracket or two negatives or something like that. But that's all you've got to do is just flip the symbol. So there we go, there's our two solutions. X is equal to negative 3 and x is equal to negative 4. So you will notice that in these questions we'll tend to get two solutions, unless obviously the two solutions are maybe the same, which can happen as well, but we're always going to get two solutions here, and in this case it was negative 3 and negative 4. Slightly different one, so draw the graph of y equals x squared plus 2x minus 3 between minus 3 and 2. Now again I'm going to do a little table for this, so we have x and y, and it's between minus 3 and 2, so minus 3, minus 2, minus 1, 0, 1, 2. Now this is a slightly more complicated one for us to sub in, because to find the y coordinate you have to do x squared, add 2x, take away 3. So I want to write these down nice and carefully. So I'm going to start with 2 again for the positive one. So we have 2 squared plus 2 lots of 2, take away 3. I'm just going to work that out nice and slowly. 2 squared is 4 plus 2 lots of 2, which is 4, take away 3. So 4 plus 4 is 8, take away 3 is 5. So my answer there underneath the 2 is going to be 5. Now I need to follow this process for all of them, but the one thing I do need to be careful of is when we get to these negative numbers. So up here where I put 2 squared in, just here, we should really make sure we keep that in a bracket, because as we get down to those negatives it's going to have a big effect on that, and we'll see what happens when we get to them. Now I'm going to do the other ones a little bit quicker. Let's have a look. So 1 squared is 1, add 2 is 3, take away 3 is 0. 0 squared is 0, add 0 is still 0, take away 3 is negative 3. And here's where we need to be careful. So the first one here is -1. So I need to put, if I'm going to do this on a calculator, I'll write my working out down. -1 squared, add 2 lots of -1, and then take away 3. Now the reason you have to put this in a calculator is because if you put -1 squared without the brackets, it will give you the answer -1. It will square the 1 and put the negative with it rather than doing -1 times -1. Squaring a negative number makes it positive, so -1 squared is 1, add 2 times -1 is -2, and take away 3. So 1 take away 2 is -1, take away 3 is -4, so we get -4 for that one. There we go. Let's have a look at the next one. -2 squared is 4, add -4 is going to be 0, and then take away 3 gives us -3 again, and then onto the -3. -3 squared is 9, add 2 lots of that, so -6, so 9 take away 6 is 3, and then take away 3 again gives us 0. So you can probably see a little bit of a pattern here. Look, if you look at that -4 in the middle, either side of that we've got -3, either side of that we have 0, and then we have the additional 5 there. But let's just plot these and see what it looks like. So -3 to 0 is there, -2 to -3 is there, -1 to -4 is here, 0 to -3, 1 to 0, and 2 to 5, which is all the way up there. There we go. So this forms a quadratic curve, a parabola, and we just need to draw that with a nice smooth curve as best you can, going through all the points, making a nice smooth curve. And there's our graph drawn. Just as a note, we could also have a cubic graph. So we could have an x cubed up here, and we just treat that in exactly the same way, subbing the numbers in very carefully using brackets, and it tends to be that a cubic graph has this sort of shape, so just be careful. There are some others as well. We could have a reciprocal graph, where we have something like y equals 3 over x, and that has a different look again. It has this sort of curved shape within the positive part of the graph. So there's lots of different graphs that we can have a look at, but just treat it all in the same way and plot the points very carefully, joining them up with nice smooth curves. So find an expression in terms of n for this sequence. So we're going to do the nth term, and then it says hence find the 50th term. So what I always like to do is draw these little loops just to see what times table this is related to, and from 3 to 7 it goes up by 4, and then it keeps going up by 4. So this is related to the 4 times table. Now the expression for the 4 times table is 4n, if we do it in terms of n. Now this is obviously not the 4 times table though, is it? Because the 4 times table, if I write it above, is 4, 8, 12, 16, 20. And all of these numbers are 1 less. Look, from 4 to 3 is -1, from 8 to 7 is -1, so it's the 4 times table, but it's had 1 taken away, and that is our nth term there in terms of n. There is also a little trick that you can apply on this. You can go backwards 4, so if we go back 4, we get the number -1, and that always tells us how much smaller or how much bigger it is than the times table we're looking at. So it says hence find the 50th term. Well, here's our little code, 4n minus 1. To find the 50th term in the 4 times table, you do 4 times 50, and it's no different for this one, but it's the 4 times table take away 1. So we're going to sub it in, and we get 4 times 50, or 4 lots of 50, but then we have to take away 1. 4 lots of 50 is 200, and 200 take away 1 gives us 199, and that is our 50th term. Just thinking, if you didn't have this nth term, you'd have to just keep counting up from 19, so you'd go 23, 27 and so on, and you'd have to keep counting up to the 50th term, and it'd take you quite a long time. So this is a nice little shortcut for that. Okay, so when it comes to length conversions, there's a few things that we need to know. So one thing that we need to know is that 1 centimetre is equal to 10 millimetres. Okay, and a lot of these things you can see on your ruler, but obviously not when it comes to centimetres to metres. When it comes to centimetres to metres, we need to know that 100 centimetres is equal to 1 metre, or we could say that 1 metre is equal to 100 centimetres. So obviously we need to know these. You can also need to know kilometres as well, and for that we need to know that 1 kilometre is equal to 1,000 metres. So you could obviously have questions on any of these conversions, but if we look at these two that we've got here, for starters we've got change 350 centimetres into metres. Well, there are 100 centimetres in every 1 metre, so if we divide this by 100, that would just mean hopping the decimal in 2 places, and we would get 3.5 metres. So that's one conversion that we could have. This one's a little bit harder. We've got 8.3 meters into millimeters. And you'll also notice that in the first question, the actual units were given to us in words. And here they're just given to us as M and double M there for millimeters. So we could have either of those. But for this one, it's a little bit trickier because we're going from meters, which is in this conversion here, down to millimeters, which is in this conversion here. Now you can always learn the conversion between the two, but I think it's easier here to first convert it into centimeters and then convert it into millimeters. So to convert it into centimeters, we would want to multiply the 8.3 by 100, as there are 100 centimeters in every meter. So 8.3 multiplied by 100 just means hopping the decimal over the 3 and then over again, which would make it 830. So it's going to be 830 centimetres. Now every centimetre has 10 millimetres in it, so we're going to multiply that by 10 to convert it into millimetres. So we'd write 830 multiplied by 10, and obviously just adds a 0 on the end there, so that's just going to be 8,300, and that is millimetres. And there we go, that would be our final answer. I would obviously just take the same approach if we had kilometres involved, so we would divide or multiply by 1,000 to turn the kilometres into metres or the metres into kilometres. And there we go, there are some of our length conversions. Okay, so working out 45% of 64. It's a little trickier here because it doesn't end in a 0, but just straight away let's think about our process. So we're going to work out 10% straight away, and we'll work that out in just a second. We're also going to need 5%, so we'll have to work that out as well, which again we'll work out in just a second. And then we're going to need to get to 45%. So in terms of what I'm going to actually need here, I'm going to need 4 lots of the 10% and 1 of the 5%. 4 lots of 10 would be 40%, 1 of the 5s is 5%, so combined there, that's going to give us our 45%. So let's work out our 10%. Now we've got 64, so to get 10%, divide it by 10, so hop the decimal in, and we get 6.4. So our 10% here is going to be 6.4. And again, we're going to want to halve that for 5%. And again, if you are struggling to halve these numbers at any point, don't forget you can always just divide it by 2 using bus stop just to the side if you need to. 2 goes into 6 3 times, keep your decimal point in place, and 2 goes into 4 twice, so 3.2. And there we go, 5% is going to equal 3.2. So we want 4 of those 6.4s and we want 1 of the 3.2s. And now again, you could multiply 6.4 by 4, or you could just add them all together using column addition. So we want 4 of those. Again, if we go beyond 40%, you've probably got quite a few there and you probably want to multiply them instead. But not too difficult for us to just add those together. So what do we get? 4, 8, 12, 16 plus the 2 is 18, so carry the 1, and then 6, 12, 18, 24, 27, plus the 1 is 28, so we get 28.8, and there we go, there is our final answer, and that is 45% of 64. Again, just being very careful when you do that. Obviously I've added them together quite quickly, so take your time with it, but just as I said before as well, you could actually have just done 6.4 and multiplied it by 4 instead if you prefer to use a multiplication method. But if you are going to do that, don't forget to take the decimal out before you multiply, so we would have instead done 64 times 4 and then hop the decimal in at the end and then added the extra 3.2. So arguably that might be a little bit longer than just adding it together. I think if you just add them together, it's pretty quick and everybody's normally pretty happy to do column addition. So if we want to get this without a calculator, all that we actually have to do is follow our process for working out a percentage, and that is to obviously start by working out 10%. So work out 10%, which is 12, and for 20% we can double that, so 20% would be 24. And then we're obviously increasing by a percentage, so we would increase by this 24, so we just add that on to the 120. So 120, add 24, and that comes out as 144. So we know the answer is 144, so for this type of question, why would we bother using a multiplier? Well, to be fair, for this type of question, we probably wouldn't. It probably could be quicker for us just to work it out without a calculator, but not all questions are going to be this simple, and not all percentages are going to be as simple as 20%. So we need to have a method for if it's going to be a little bit trickier, surely there must be a faster way for us to do this with a calculator, and there is. So we're going to look at that 20% and we're going to figure out what we would actually multiply by to increase by 20%, and therefore you know, if it was 17% or 5%, what would we actually be able to multiply by? And it all comes down to thinking about that as a percentage more than the original. So the original amount that we have, we could think about as being 100%. And I'm going to draw it as a little bar. So we've got 100%, and we are going to add on an extra 20%. So that's almost like we're extending the bar, we're making it 20% bigger. Now, if we think about that, what is that as an overall percentage? Well, we've got 100% and we've got 20% there, and overall that is 120%. And if we want to increase by 20% to get this 120%, we need to think about what 120% is written as a decimal. Well, 100% isn't actually written as a decimal, that would just be the number 1. So the 100% would be written as the number 1, but what would go after the 1? So it'd be 1 point something. Well, thankfully, it just reads as it does just above. It's 1.20. So that 0.20 there is the extra 20% on top of the 1, which is our 100%. So it's the extra 20% on top of the 100%. And that right there is the decimal that we would need to multiply by. We would just multiply by 1.20. Obviously, you don't need to put the 0 at the end, so you would just multiply by 1.2. And 1.2 is the decimal multiplier to increase by 20%. And if you get your calculator now, because we're obviously using a calculator method, and you type in 120 and you multiply it by 1.2, then you will get the 144. So let's type that in, 120, multiply it by 1.2, and in this instance we actually do get 144. So you can see it actually calculates that percentage increase for you. So obviously, when we are using a calculator method, we need to know a few things here. We need to know obviously how to turn the percentage into the decimal, and obviously thinking about the fact that it has to be 1 point and then that increase in that decimal there. So another example that we could think about is, let's say we were increasing by, and let's go with 30%. So what would an increase of 30% be? Well, instead of being 1.2 or 1.20, instead it would be 1.30. And it just follows on this little pattern. So you don't have to write down the full 120% and draw the bars. All you have to know is that if you are increasing by a percentage, it's 1 point and then whatever that percentage is afterwards. So in the case of 20, 1.20, in the case of 30, 1.30, and that's what we'll multiply by. Okay, so this question says Alice buys a pack of 10 drinks for £4. She sells all 10 drinks for 50p each. Work out Alice's percentage profit. Well, her original cost then is £4, so we've already spent the £4 on our 10 drinks. She's then going to sell them all for 50p, so we need to do 10 times 50p. So 10 times 50p, and again you can work that out however you choose, but that comes out as 500 pence. There we go, and we will probably want to convert that into pounds because the other one's already in pounds. Although we could change the £4 into 400p, I'm just going to turn this into £5. There we go. So now we can actually work out how much profit that she's made, because she's bought them for £4, sold them for £5, so she is going to make £1 profit. And there we go, and now we've got our £1 profit. We can just apply that to this question, just like we have on all the others. So the profit is 1, and the original was 4. So we can do £1 out of 4, which straight away comes out as 1/4. So that's a very nice one for us, because that is straight away going to be 25%. Of course, if you want to multiply that to make sure we get the right number on the bottom, you multiply by 25 to make it 100. That's not drawn that 25 very nicely. Let's write that carefully. There we go, times it by 25, and you'll get 100 on the bottom, and you get 25 on the top, which is 25%. And there we go, there's our final answer. Again, you could work out that percentage of the original. 10% of £4, obviously you get into decimals here, but 10% of £4 would be 40 pence. We're trying to get to £1 profit, so we'd probably also want to get the 5%, so 5% would be 20p, and then we can build that together. We could add another 10% in, which is another 40p, and in total that now makes £1, and the total percentage there was 25% when you add those three together. So there we go, that is obviously approaching one of these problems. We had a little bit of working out to start with. Let's have a look at one that's slightly trickier than this then before you have a go at your final questions. Okay, so share £240 in the ratio 5 to 7. So if we're splitting this in a ratio, let's have a look. We've got in total here 5 plus 7 equals 12 parts. Okay, so if we split this into 12 parts, we could do 240 and divided by 12. And 240 divided by 12 is 20. So in each part there's £20. Now there was 5 parts and 7 parts, so those 5 parts are going to be 5 lots of 20, which would be £100, and the other part there was 7 parts, and that times 20 would give us £140. So splitting it in the ratio 5 to 7 gives us 100 to 140. And the last little check you can do here is just to add these two together, just to make sure you do get that £240 that you started with. So we're happy with that as a final answer. So Craig and Ian share some money in the ratio 8 to 3. Craig receives £32. How much does Ian receive? Well, C to I, Craig to Ian, was in the ratio 8 to 3. And it said that Craig receives £32. So that is this first number 8 here, that is 32. So what we've got to think about is how do we get from 8 to 32? So 32 divided by 8, which we can do to the side, 32 divided by 8 is 4. So we must have times by 4 to get there. So if we do the same to the other side, times by 4, 3 times 4 is 12. So there we go. How much does Ian receive? Ian receives this 12. So I'll just say £12. Final answer. So Emily and James share some money in the ratio 4 to 7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4 to 7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them. So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go, so they share £77 between them. 3 tins of beans and 4 jars of jam weigh 2,080 grams, and the total weight of 5 tins of beans is 1,800. Work out the weight of 1 tin of beans and 1 jar of jam. Well, straight away we can work out the weight of 1 tin of beans from this, because it says 5 tins of beans is 1,800. So if we do 1,800 and divide it by 5, we get the answer 360. There we go. We might have to do a bit of bus stop for that, but we can do that. 5's into 1,800. 5 into 18 goes 3, remainder 3. 5's into 30 goes 6, and then 0, so 360 grams, and that is for the tin of beans. So tin of beans. There we go. It then says 3 tins of beans and 4 jars of jam weigh 2,080 back in the first line. So if we work out the weight of 3 tins of beans now, well, 3 of those would be 360, 360 and 360. And if we add those all up, we get 9, 10, 1,080. So that's the weight of those tins of beans. So if we subtract that away from this original amount, so 2,080 take away 1,080, that leaves us with 1,000 grams. So those 4 jars of jam, so 4 jars equals 1,000 grams. And we want to know the cost of 1, so we can divide that by 4, and it gives us 1 jar equaling 250 grams. So there we go, 1 jar is 250 and 1 tin of beans was 360. So a car has to travel 30 miles along a motorway in 24 minutes, while the car have to travel faster than 70 miles an hour to get there in 24 minutes. Now I'm going to do this as a non-calculator one, then we'll have a look at one that's maybe a little bit more calculator based. But if it has to travel at 70 miles an hour or more, now 70 miles an hour means that we go 70 miles in 60 minutes. So 70 miles equals 60 minutes. Now what we can do is we can actually start to break this down. So if I have a look, what can I divide both sides by? So if I can divide both sides by 10, that would mean I would go 7 miles in 6 minutes. Okay, dividing that by 10 as well. So you can have a look to see if you can ever break these down this way. So 60 divided by 10 gives us 6 minutes. There we go. Now it says we've got to go 30 miles and we've got to go there in 24 minutes. Now just having a look at this speed here, 7 miles equals 6 minutes. So travelling at this speed, if I wanted to get to 24 minutes, have a look, 24 minutes, we would times that by 4. So if I do the same to the other side and times that by 4, that gives us 28 miles. So travelling at 70 miles an hour, in 24 minutes we would go 28 miles. And the question said a car has to travel 30 miles. So it's not actually going to be able to make that 30 miles in 24 minutes. It's only going to be able to go 28 miles. It would have to go over 70 miles an hour. So I would make obviously that statement no. Okay, it's only going to go 28 miles, or it's not going to be able to do it in that sort of speed. Okay, so as you can see, this particular graph is incomplete. So let's have a read and see about how we're going to complete this. It says here is part of Carl's journey from his house and back. Here is the distance time graph for part of his journey, and it says part of his journey because it's not been completed. So for part A, it says work out Carl's speed for the first 30 minutes of his journey. So we need to be careful again because that's not necessarily the entire line there, but in this case I do think that is going to be the full line as 30 minutes takes us up to this point. So that is for his full journey. So we're looking at the speed from the start of the journey, which is down here, up to the top of the journey where the other mark is. So obviously in order to work out speed, we're going to want to use our speed distance time formula, which again we'll write down in a formula triangle, and that is going to be speed is equal to distance divided by time. So we need a distance and we need a time. And again, we're going to write this in kilometers per hour, although it doesn't actually say to, so we could actually write this in kilometers per minute. But we're going to assume for all of these speeds, it's going to want it in that format. So in terms of the distance, that is a distance of 20 kilometers, which we can obviously read by looking just to the left here. So we have 20 kilometers as our distance, and we're going to divide that by, and let's just write it down here so we don't forget that number. It's 20 divided by the amount of time. Now again, this amount of time, as we've been told in the question, was 30 minutes. So if we're going to write that in terms of kilometers per hour, then we're going to divide that by 0.5. Again, converting those minutes by doing 30 out of 60 and spotting that that's a half, or typing it into your calculator. So 20 divided by 0.5, and again we can type this in on the calculator, it comes out as 40. A half fits into 1 twice, and therefore it doubles your answer, so it fits into 20 40 times. So just a quick way of dividing by a half if you don't have your calculator on you. So that's our answer for part A, and again that was in kilometers per hour. So we could write that as kilometers per hour. On to part B here, it says Carl spends 15 minutes at the shops, and we can see that on part of the journey. So if we get rid of this, we'll highlight that point, and as you can see, he spends 15 minutes. You can see that each of those squares is 5 minutes down the bottom, so we're happy with that. That is completed as being the 15 minutes. It says he then travels back to his house at 60 kilometers per hour, and to complete the travel graph. So actually what do we need to find here? Well, we need to find the time it takes him so we know exactly what time it's going to finish. For example, down here, we're at 45 minutes. Now if it takes him 10 minutes to get home, he would finish here at 55. And we could connect our line using a pencil and a ruler and complete our distance time graph. But we actually want to figure out the exact time there. So at the moment we're at 45 minutes, but how are we going to figure out the time? Well, it again comes back to our speed distance time formula. And you can see if you look just at the top here, that if we cover up time, then time is going to be working out by distance over speed. So we want to get the distance and divide it by the speed. And that's quite good because we've been given the speed in the question, and the distance we already know because we've got it over here. It's 20 kilometers from his house. So we need to do the distance, which is 20, and this is for part B. And we're going to divide that by the speed, which is 60. So 20 divided by 60. And if we do 20 divided by 60, what answer do we get? Well, 20 divided by 60 is going to come out as a third. So how are we going to interpret that in terms of a time? Because that is in hours. So 20 divided by 60 comes out as 1/3. Now,
this is the difficult part for these questions, because you have to remember that that is in hours and we want it in minutes. So what is a third of an hour? Well, a third of an hour we can work out. We could do that, and we can do the working out to the side because we've got 60 that we want a third of. And a third of 60 you can work out in two different ways. Either you could just straight away times that by 60 on your calculator. So just type in times 60 once you've got your third value, and it will come out as 20. Or you could actually work it out using a fraction of an amount, and you could do 60 divided by 3. Again, that comes out as 20. So the working out here, we want to get a distance there that ends after 20 minutes. So at the moment we're at 45 minutes, and 20 minutes on top of that is going to take us to 65 minutes. And again, you could write that down. I'm just going to write down that it was equal to 20 minutes, so we have the working out down, because you always want to make sure you show your working out for these questions. So again, you want to get your pencil and a ruler, and you just want to connect that up using a nice straight line. And that would complete this distance time graph. Now you don't have to get rid of all of your working, but just make sure that that doesn't get confused with any of the other lines. You don't want lots of lines drawn on there, as it might get confused with the actual line that completes the graph. So there we go, that would be how we would complete our graph. Now obviously the difficult part on this question was that completion part. So let's just run over that again. So we spend 15 minutes at the shops and then travel back at 60 kilometers per hour. So we took the distance, which we got from our formula triangle, and we divided it by speed. 20 was our distance from home, 60 was our speed given to us in the question, and that came out as a third. That was in hours, so we multiplied it by 60 because there are 60 minutes in an hour, and it gave us our 20 minutes. Because down the bottom it was in minutes, that allowed us to then draw 20 minutes on top of our 45 minutes, which allowed us to complete the graph. So hopefully you were okay with that. Obviously this is the most difficult part of it, so it was worth talking about that again.
Okay, so this is quite an interesting question because this is talking about density, and obviously we're doing this non-calculator. And normally density is a calculator-based question, so hopefully we're going to have some nice numbers. Now as soon as you see that word density in a question, you're going to want to write down your formula, whether you use a formula or whether you use a formula triangle. So I'll write down the formula triangle because that works for everybody then. So that's going to be density is equal to mass divided by volume. Now this question says it wants us to work out the mass. So straight away, if I cover up the mass, that means I'm going to do density and multiply it by my volume. So this question gives us a cube, and it says the rubber cube has side lengths of 4 centimetres. So in regards to this image here, we've got 4 centimetres across there, 4 centimetres here, and a 4 centimetre height. So to work out the volume of a cube, you would just multiply all those numbers together, or in other words, 4 times 4 times 4. Obviously take that in stages. 4 times 4 is 16, times that by 4 again, and that is going to be 64. So 64, and the units are centimetres, so it's 64 centimetres cubed. Now it gives us the density. It says the density is 1.5, so we know to do this we do the density 1.5 and multiply that by the volume, and the volume is 64. So we just need to do 1.5 times 64, which isn't too bad. When you are multiplying by 1.5, that just adds on an extra half. Obviously you can hop the decimal out, you could do the working out to the side. So if we do that, we'll get 64 times 15, 5 times 4 is 20, 5 times 6 is 30, add the 2 is 32. Put our placeholder in. 1 times 4 and 1 times 6 is nice and easy. And if we add that together, 0, 6 and 9, so you get 960, and then you just have to hop the decimal back in one jump as we took it out at the start. So when you jump that in, you get 96.0, so that would be 96, and in the units it said grams per centimetre cubed, so that would be 96 grams as our final answer. So there we go, we'll get 96 grams. So as you can see, we can have density questions that are non-calculator, but you're going to tend to get nicer decimals involved. They're just going to be a little bit nicer for your calculations.
Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. If you think about any coordinates on that line, the x-coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point.
and we just go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that would be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well that you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal. So we could have that one as well where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way. So we could also have to reflect in a diagonal line. But again, you just follow the same process, counting diagonally. Right, okay, so something slightly different again. We've got the front elevation and plan of a solid are shown on the grid. And on the grid, draw the side elevation from the direction of the arrow. Okay, so we're looking at it from the front there, and again, thinking about the front elevation, we're looking at it from this angle here. Now again, thinking about the logics of the last question, it doesn't matter how wide it is for the moment, but the height of that from the front is going to be exactly the same height as it is over here. Okay, the height isn't going to change, so we can draw that in from base to the top there as being the same height. Now looking at the plan, we can see from the plan that it's only 2 squares wide. So from the front, we're only going to see 2 squares across. There we go, and that's the shape we're going to see. A rectangle that looks very similar to the last one. But there are a few little kinks here where the sort of depth of the shape changes primarily, and let's just get rid of some of these. We've got that one down the bottom, okay, so we want to make sure that that matches up as well. So we've got that one there, that's going to be in there, and we've got this one here, that's going to go in there, and there we go, that's what it's going to look like. Okay, it's almost like a little set of stairs. It'd be quite difficult to actually draw this, but imagining what it kind of looks like, I'll do my best. Let's have a think. It will go something like that. It's like a little set of staircases. I probably shouldn't have started drawing this because it's not going to look very good, but here we go. I'll try my best. It's going to look something like that. There you go, like a little set of steps, okay? And as you can see, this little step here is slightly higher up than the 2 below it, okay? As you can see from the diagram there, it's 2 squares up for that one rather than just 1 square up. So that's the shape that we're actually drawing. And obviously, if I sort of colour code this, look, we've got this face here that we're seeing as this one down the bottom. We've got the next one up, this face here that we're seeing here. And then we've got our final face, okay? In fact, let's do that in a different colour. We've got the final face there that we're seeing as this part here. Okay, so it does obviously help if you can kind of visualize it as a 3D shape, although it's not the easiest to do. But there you go, that's how you go about drawing this one. Okay, so there we go, that's that one, drawing our, what elevation were we drawing? We were drawing a side elevation, there we go. So that was how we draw our side elevation using our other elevations, and it can help to be able to draw that 3D shape before you actually go about drawing the elevation. Okay, but if not, you can always think about the logic I just used there, making sure it was the same height, making sure it had the same width as the plan, and obviously just matching in any of those little changes of depth there with those lines and indicating those. But there we go. Oh dear, got rid of that in right in the last step. There we go, put that back in. There we are, so let's have a look at our next question. Right, okay, so in this question we're actually gonna have to draw the 3D shape, okay? So we need to have a think about what this is actually gonna look like. So it says the diagram shows the plan, the front and the side elevation of a solid shape drawn on a centimetre grid. It says draw a sketch of the solid shape and give the dimensions of your solid on your shape. Dimensions of the solid on your shape, okay? So just be careful with that, because obviously giving the dimensions means we've got to put the lengths on. So we've got to put how many centimetres wide or high or whatever it is. Now looking at this, look, from above it's a circle, and then from the front and from the side it's a rectangle. And there is only one shape, and this is just about knowing your shapes really. There's only one shape that's a circle from the top and a rectangle from the side, and that is a cylinder. Okay, obviously when we draw a sketch of that, we don't see it as a circle as a sketch. It kind of looks a bit like an oval sort of shape. But then we have the bit coming down. I'm not drawing that very well. Let's draw that line in again. There we are, and a slightly bit of a curved base there, and you could even put the sort of dotted base at the back that we can't see. But there we are, that's a cylinder, and if you can imagine looking from above,
you would see that circle, but from the side there, if we sort of dropped our heads down and we were standing in front of it, we wouldn't see that circle on the top, we'd just see the big rectangle there from the front, the side, the back, the left, whatever side you stand on, you would see that rectangle. So finishing this off, obviously we've drawn a little sketch of it, we've just got to add in the dimensions. There's 2 dimensions we want to add. One is the width all the way across here, and if we have a look, that goes across 4 centimetres, it's on a centimetre grid, so that's going to be 4 centimetres there. And then we also want to draw the height in. And let's have a look at this rectangle over here. It was 1, 2, 3, 4, 5. There you are, it goes 5 centimetres up. So we'll also add that in as well. And that is 5 centimetres. Right, there we go. Wow, that's how you draw one of these, obviously from a sketch. It does actually mean that you've got to know your shapes quite well. You can imagine there's probably a couple of other shapes that you could have. Thinking about like a cone, obviously the front and the side of a cone wouldn't be a rectangle, but we'd have a sort of, there we go, this sort of shape from the front and the side if it was a cone. Okay, you'd still have a circle from the top. You might actually have a point in the middle if it was a cone, because you'd see that little tip of the cone as well. But there's just another kind of shape that you can imagine looking above being a circle, could also have a little cone as well. But there we are, that's how we go about drawing one of those, and obviously just making sure you read the question carefully. Obviously when it says give the dimensions, you need to make sure that you actually add those on from the grid as well. But there we go, let's have a look at our last question. Working out the size of the angle between this regular octagon and regular hexagon. So there's different ways that you can approach this, but we need to know what the angles inside a hexagon all add up to and what the angles inside an octagon add up to. There's different ways of doing this. You can do the 180 list rule, so you can keep adding 180, so 3 sides is 180, 4 sides is 360. 5 sides is 540, and you can keep doing it this way, or you can apply a bit of a formula. So I'm going to go for the formula, even though I've started writing this down, but that is an option there that you can use. So for 6 sides in a hexagon, we take away 2, so 6 take away 2, which is 4, and then 4 times 180 tells us the total amount of, oh, that should be a times sign, let's change that. 4 times 180 gives us the total amount of angles in a hexagon, which is 720. So all the angles inside a hexagon equal 720, and there are 6 equal angles in there. So if we divide that by 6, 720 divided by 6 gives us 120 degrees. So all of these angles in the hexagon are 120. Obviously we're concerned about this little area here in this question because we're trying to find the angle between them, but we've got the angle in the hexagon, and that's really important. When you see these words regular hexagon and regular octagon, always just work out the interior angle and label it all over the diagram. So moving on to the octagon, same process, 8 sides, take away 2 is 6, and then times that by 180. There you go, and 6 times 180, which is okay if you have a calculator. If not, you just have to work that out, but 6 times 180 is 1080. And again, it's got 8 equal angles, so if we divide that by 8, 1080 divided it by 8 gives us 135 degrees, and again, we can just label that all over the diagram. So 135, 135, and lots of these, but I'm concerned again with this little area here. So angles around a point equal 360, and at the moment we've got 2 of these angles, kind of like a jigsaw. So if we add these 2 together, 120 plus 135, at the moment we've got 255 degrees, and we need it to add up to 360. So to finish that off, if we do 360 and take away that 255 that we've just worked out there, we get a missing angle of 105 degrees, and that's our final answer there, 105 degrees, which we could always label on the diagram as well, 105. And there we go. So whenever you see these questions where it says regular octagon, regular hexagon, okay, just spot these bits of language here, just work out their interior angles and label it all over the diagram. Working out the volume of a cuboid is quite nice and simple. I do like to do it in a particular way though, just so it's the same for all of these shapes where we have a constant cross section. So this cross section, I'm going to have a look at this front face just here. So I'm first going to just work out the area of that, which is 8 times 12. So 8 times 12 gives me 96, and that is the area of the cross section, 96 centimetres squared. And then to get the volume, we just times it by however far back the shape it goes, which is the same as that 14 back there. So times that by 14, 96 times 14 will give us our volume. So 96 times 14 is 1,344, and it's a volume, so we put centimetres cubed, and that's how you work out the volume there. That works for any shape. We've got a constant cross section. If you imagine, sometimes we have these triangular prisms, and sometimes we could even have a trapezium face prism there. Okay, anything with that constant cross section, you always work out the area of this front face to start with, the cross section, and times it by the distance it goes back. That same logic can be applied to a cylinder. So our cross section this time is a circle. So all we've got to do is work out the area of the circle, remembering area equals pi r squared.
So working out the area of that circle, it's pi times 4 squared, which again is 16 pi. We can write that as a decimal. Now what I'm going to do is I'm just going to leave it as 16 pi for the moment, so I don't have any rounding errors here, but you can write it as a decimal at this point, but I'm just going to leave it as 16 pi. Now once you've got the area of the cross section, you just times it by how far it goes through the shape, which in this case is this 15. So all I've got to do is times that by 15. So 16 pi times 15, which comes out as 240 pi, which is also a decimal, so it just depends on how the question wants the answer here. So it's 240 pi. Now there are a few non-calculator questions, and again there's more of these on the higher, but two here that we really need to know, and that is sine 30 and cos 60. Now the value of sine 30 is 1/2, as is the value of cos 60. So they're both equal 1/2, and they're really good ones to make sure that you know for these non-calculator papers. Okay, so do remember those ones, sine 30 and cos 60, and they're both equal 1/2. And let's see how we can use that. So this question says, given that sine 30 is 1/2, which hopefully we know anyway, work out the length of AB, and AB is this side here. So let's label this triangle up. We've got the opposite, we've got the hypotenuse, which it's asking us to look for, and this is our adjacent again. Now again, we're not going to use the adjacent here, we're just going to use O and H. And if we remember our little formula, look, SOH has the O and the H in, and we're looking for the hypotenuse. There we go. So if we're looking for the hypotenuse, we cover up the H and we need to do O divided by S. So S is my sine 30, so if I was to do this on a calculator, I'd have to do 4, and I'd have to divide it by sine 30. Okay, but this question's actually told us that sine 30 equals 1/2, so actually what I'm doing is 4 divided by 1/2. I'll write that as a decimal, it makes it a little bit nicer to see, but 4 divided by 0.5. So actually it's just asking me to do a number sum now, which is 4 divided by 1/2, and if you divide by 1/2, it doubles the answer there, doubles the number. So 4 divided by 1/2 is 8, so my answer would be 8 centimetres. There we go. And of course that could go the other way around as well. I could have to do a times. So had it not given me this 4 here, maybe it had already told me that this was 8. Then instead I would do 8 times 1/2, doing S times H, so 8 times 1/2, and that would give me the 4 here that's been given as the opposite. So we could have it either way.
Okay, so when we're looking at a pictogram, we really need to look at the key. So the key here on the right hand side, which I'll just highlight, says that a circle represents 10 tins. And it says here that some tins of paint were sold on Monday, Tuesday and on Wednesday. It then tells us that on Thursday 60 tins were sold, and on Friday 35 tins were sold, and it wants us to complete the pictogram. So for 60 tins, that's going to be 6 of those circles, as they represent 10 each. So we just draw 6 circles into our pictogram, nice and neat, and there we go, there's our 6. For 35 tins, we're going to have to use part of a circle, so we'll get the 3 circles in that represents 30, and then we just need to draw half a circle as best as you can, which is going to represent those 5. So obviously drawing that nice and neat, and you can probably do it a little bit better than me when you've actually got the paper in front of you. Now for part B, it says more tins were sold on Tuesday than on Monday. How many more tins? So we just need to count from the pictogram. So on Monday, there are 3 circles, that would be 30 tins. And on Tuesday, there are 4.5 circles, so that would be 45 tins. So in total, that's an additional 15. You can show you working out. That's 45, take away 30, which is going to equal 15 extra tins that are sold on Tuesday as opposed to Monday. And there we go, there's pictograms. Okay, so this question says Harry and Seamus recorded the number of minutes they spent revising last week. So the table shows some information and it wants us to draw a suitable diagram to show this information. There's a couple of options. We could do obviously we're going to be drawing a bar chart, but there are a couple of different bar charts that we could draw. Now, regardless of which option we're going to go for, we're going to have to scale the axes. And when it comes to one of these, I'd probably draw a dual bar chart where we have the bars next to each other. So if we have a look at this, we're just going to have a look at the information and identify which one of those is our largest number, and that is 40. So we're going to need to go up to at least 40 on the left hand side. So if we just go for 0, 10, 20, 30 and 40, and then just make sure that you label those 0, 10, 20, 30 and 40. And then we're going to want to label the axes there, and that is going to be minutes. So we'll just put here minutes to the side, and then we're going to go down the bottom. So to make sure that we can draw this correctly, we want to label the days. So we're going to go for Monday, Tuesday, Wednesday, Thursday, and just label them in. So for here, we're going to go for Monday, and let's just imagine we're going to have our bars kind of drawn side by side. So it's going to go about that much, so that would be Monday. And then we're going to leave a gap between those. So our next ones are going to go sort of here. We can just sort of label this in every 5 squares I'm counting, just to make sure that it's nice and neat, and hopefully this all fits. So that could be Monday there, we'll leave a gap, and then we'll have Tuesday here, leave a gap, Wednesday, leave a gap, and then we'll go for Thursday just over there, and we'll separate the Tuesday and the Thursday just like that. Okay, so that also needs labelling, so we'll put days underneath, and we'll just write that that's going to be the days down there. Now we just need to draw the bars in. So if we go for Harry first, and we'll do 35 for Harry. So if we draw a bar coming up, obviously just between 30 and 40, and that'd be 35, and then 10 for Seamus. And we'll draw that in. Now obviously we can't tell at the moment which one is Harry and which one is Seamus, so we're going to have to draw a key. So what I'm going to do is I'm just going to slightly shade in Harry's bars, and then I'm going to draw a little key, and we'll draw that at the end so we know we've got some space. So for Tuesday, we're going to have 30 for Harry, and again I've left a gap, so now I've got my bar here for Harry, and then I'm going to do Seamus as well, which is going to be 20, and again just going to shade in Harry's, and don't need to shade it in massively, just a little bit of shading. Next one is 25, so 25 for Harry. And there we go, let's draw that across, there we go, and we're going to have 25 as well for Seamus. There we go, and I've not drawn that perfectly there. You could probably do this better when you have a ruler and a pencil. I'll try and make it as neat as I can, and then again shading in Harry's. And then we've got our last one here, which is 20 for Harry, and we've got 40 there for Seamus, and that was the largest out of all of them, so up to 40. And drawing that in nice and neat, not forgetting to shade Harry in. And then somewhere on your graph or to the side of the graph, you're going to want to draw a key. I'm going to do it over the top of the graph just because I'm limited on my space, but I'd normally draw it to the side. In fact, I could probably fit it into the side, so I'm just going to draw a little box that's shaded in, and I'll just put Harry next to that. And then I'll just do my blank box, that's Seamus. There we go, and I'll just put the key above that just there. Right, there we go. So that is how we would go about drawing our bar charts. Now you could draw a different type of bar chart as well, where the bars are stacked on top of each other. That's fine to do. I would always go against drawing that if I had the option, because obviously if we do that, we're going to have to scale the numbers up a lot more because we have to look at their totals instead. So for example, we would have to scale Thursday up to the number 60 because we'd only go up to 20 for Harry and an additional 40 on top for Seamus, but you could go about doing that as well, but obviously given the choice I would draw one of these bar charts. So there we go, that's how we go about drawing one of these bar charts.
Okay, so reading from a stem and leaf, it says the speed of 27 cars, work out the median and work out the range. So to work out the median, I want to know which one's in the middle. We can take quite a nice approach for this. We can just cross numbers off either side until we get to that middle number. So if there's 27, I'm going to cross off 10 from each side at least, so I can start to get from the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then going from the back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm just going to do one from each side until I get one in the middle. So 1 and 1, 2 and 2, 3 and 3, and I'm left with this one here. Don't forget the key though, it says 3-8 or 3 line 8 means 38. So that's next to the 5, so it's 5 and 6, which is 56. So the median there would be 56. Working out the range, we want to look at which one's the smallest and which one's the biggest. Let's have a look. If I get rid of some of my lines here, the smallest number there is 38, the biggest is 70. So to work out the range, which I'll do up here, so the range will just be 70 the biggest, take away 38 the smallest, which is 32 as my range there. Again, there's median and range from a stem and leaf. Okay, the table shows the probability of picking different colours. So we have red, blue, white and black, and it says the probability of white and black is the same, complete the table. So at the moment, We've got these two which add up to 0.7, and probabilities have to add up to 1. Now what we've got left over there is 0.3. I like to think of it as 0.30 because if they're both the same, we're going to have to halve that, and half of 30 is 15, so it's 0.15 for both of those, and now they add up to 1. Now for part B, it says that there are 60 counters in the bag. How many are white? Now if we look at the probability of white, which is over here, 0.15 is 15%. So really all this is asking us to do is to work out 15% of 60. And we can do that nice and easy. 10% is 6, 5% is half of that, which is 3, and add them both together, and that's 9. Now part C here, you won't be given this at the same time as question B because we already know that there are 60 counters in the bag, but it says that there are 12 red counters, and how many counters are now in the bag. So if we imagine this is a completely different question now, but it's saying that red counters here, which is 20%, is now 12 counters. So all that's actually saying is 20% equals 12 counters. Now that's okay, we can turn that back into 100% quite nice and easy. I could just times that by 5, but let's imagine it's not a nice percentage. I'd have to try and break it down to something which turns into 100. So we could divide it by 2, which would give us 10%, which is half of 12, which is 6, and then times that by 10 to get us back to 100%. Okay, again, you could actually just times 20% by 5, but I think that's quite nice just to break it down and build it back up, so 60 counters there would be in the bag. Okay, so here we've got 60 people each took a driving test one day. 21 were women, 18 of the 60 people failed, 27 of the men passed their test, one of the men is chosen at random. What's the probability this man failed his test? Now this is a little bit nicer to draw a frequency tree because we only have two options here. We have men and women, and then whether they pass or fail. So the trees are actually a lot nicer when it's just the two. Well, let's have a look. We've got men and women, and then off each of those branches they either pass or fail. I'm just going to put P for pass and F for fail. There we go, and there's the tree, and there we go, so pass, fail. So if we go about filling in the information we've got, then we've got 60 people took a driving test, so 60 at the start, 21 were women, so 21 down here, 18 of the 60 people failed their test. So let's have a look. 18 of the 60 people failed their test. So we've got these two here in failed, and that has to add up to 18. So 18 of them are going to fail. We don't know whether it's men or women yet, but 18 failed. Then it says 27 of the men passed their test. So up the men, 27 passed. There we go, that's that one. Right, okay, so that's all the information that we've got. Now we know that there are 21 women, so we can work out how many men there are. They have to add up to 60, so that's going to be 39. There we go. And now we can work out this one just here, because it's got to be 39. We've got 27 in there already, so that is an extra 12. Okay, just double check they add up to 39. Yes, they do. Now we can deal with this bit of information. Look, these two have to add up to 18. We've got the one of them there is 12, so this has to be 6. And then these two here have to add up to 21. So we've got 6 in that one at the moment, so that's an extra 15 there to make sure that adds up to 21. Now we can take the same approach as before. It says one of the men is chosen. Work out the probability that this man failed his test. So one of the men, so it's out of these 39, and 12 of them failed. So there we go, we've got 12 that failed out of the 39 men. There we go, and there's our probability.
If you're only going to watch one video this year, this is the one. With GCSE Maths right around the corner, I'm going to show you 3 easy steps to maximise your grade using minimal effort. Step 1, head to the TGMT hub, go to the bottom of the page once you've logged in and access the revision quiz. From here you can answer a question on every topic within the GCSE. You can go through working through each question and making sure that you practice absolutely everything. Once you've done that, you are going to get a full report that shows you exactly what you got right and wrong on all of these questions. So work your way through the quiz and then access your report. From here you can see on individual units what you need to work on and what you've already secured. So identify what you need to work on. Then we're on to step 2. Head back to the hub. You can go through the units, you can go to the exact one that you know that you need to work on, and you can access all the individual topics within that unit. Once you've done that, you can pick the topics that you want to work on, watch the video, and you can complete a topic quiz for that particular topic. So work your way through the quiz, answer those questions, and then you're going to get another report. That's going to show you exactly what you got right and wrong, so that you know if you need to do any more work. Step 3, head back to the hub and go to the bottom. You can now go onto the upgrade quiz. On here, you're going to be able to answer questions again, different to the first, on every single topic within the GCSE. Once you've done that, you're going to get another quiz breakdown and a report that shows you exactly what you got right and wrong, so you can put any of those finishing touches in before that exam comes along. With the exams right around the corner, we need to make sure that we make revision simple. Join upgrade. Okay, so when looking at order of operations, we just need to think about those rules and the orders in which we do things. So for part A here, it says work out 2 times 5 plus 7. That's a really nice one because multiplication comes before addition. So in this particular question, we would do multiplication first, which is 2 times 5. So we'd have 10 for the answer for that. And then we'd need to add 7. And when we do 10 plus 7, we get the answer 17. So that's hopefully quite a nice one. Now for this one here, it says write brackets in this statement to make it correct. So at the moment we have 7 times 2, add 3, and that equals 35. Now if we were to follow our normal rules here, 7 times 2 would equal 14, then we would add 3, and that obviously doesn't equal 35. So it doesn't work as it is, and that means there's only one place for us to put the bracket, and that would have to be around the 2 plus 3. Of course, no matter which one you're given, you do need to check this out and just make sure that it is correct. So we do brackets first. 2 plus 3 is equal to 5. So actually we're going to be doing 7 times 5, and 7 times 5 is 35. So we're happy with that. We know it's correct, and we've checked our answer. So that's how we go about doing order operations. Okay, so when looking at some negative numbers, we can have any form of calculation or any kind of question to do with negatives, but here's an example with something to think about. So it says write one of these numbers in each space to make the correct calculation. So you just need to remember whichever number we put first here is going to be our starting number. So if we want -7, it's probably a good idea to try something down in the negatives. So if we were to put -9 here, what would we have to add to -9 to get -7? Well, if we're going to add something to -9, we're getting closer to 0 to get to -7. So we don't want to be adding a negative, we want to add a positive. So if we could add 2, and that would get us to -7. So that's one of our solutions there. But is there anything else we could have tried? Well, if we had have started with -2, we'd have to add -5 to get down to -7. So we couldn't have started with -2. What about if we started with 2? Is there any way we could have got down to -7? Well, we can add -9 to 2, because if we do 2 add -9, that would be the same as 2 take away 9, and 2 take away 9 would equal -7 as well. So we could have had -9 add 2, or we could have had 2 take away 9, which would have been equal to -7. And in each of these questions, whenever you're dealing with negative numbers, you just got to remember your starting number, and then whether you are going up or down. So if you're adding a positive, you'll go up closer to 0, or obviously above 0. And if you're adding a negative, that's actually going to be doing a takeaway. So just be careful there with your starting number and which direction you're going when you are adding or subtracting negatives. Okay, so in this question we've got some estimation. It says here, Paul organised an event for a charity. Each ticket for the event cost £19.95 and he sold 395 tickets. Paul paid costs of £6,000 and he gave all money left to the charity. Work out an estimate for the amount of money Paul gave to the charity. Okay, so let's have a think. Now he's got the tickets for £19.95 and we are going to do an estimate here, which means we're going to round all our numbers to one significant figure. So for the amount of money or each ticket, we're going to round that to £20. So we'll write £20 for that. And he sold 395 tickets. So let's round that. We'll just label it here to 400 tickets. Now, just as a side note here, if you don't round them, you can still get the answer correct. But bearing in mind we're doing a non-calculator method here, we don't want to waste any time doing £19.95 multiplied by 395 tickets when we could just do this nice easy method of using our one significant figure rounded numbers. But again, you can do it the other way, doing the full calculation, but you're going to spend a lot more time doing that. You're not going to gain any extra marks. So for this one here, if we've got 400 tickets, each one was £20, well, we're going to do 400 tickets multiplied by the £20, which is easy for us to do because we just do 4 times 2, which is 8, and then add on those 3 zeros. So that's £8,000. So he sold £8,000 worth of tickets and he paid costs of £6,000. So that means he's made £2,000 profit, because if we take the £8,000 that he made selling the tickets, take away the £6,000 costs that he had to pay, that's left him with a profit of £2,000. And that £2,000 is what he's going to give to the charity. So it says he gave all money left to the charity, so that £2,000 which he would have made, he's given it all to the charity. Now it says here, is your answer to A an underestimate or an overestimate? Give a reason for your answer. Now in our calculation we've done a multiplication, so we've multiplied two numbers together. So what have we actually done to our numbers? Well, we rounded the cost of the ticket up from £19.95 to £20. We've said they're more expensive. And we've rounded the amount of tickets up from 395 to 400. So we've said more tickets and a higher price. So that is going to be an actual larger number there that we got for the 8,000. So actually he would have made slightly less than £8,000. And then when we took away the 6,000, we'd have had a number less than the £2,000. So our answer is an overestimate, and we would have to give a reason for that. So our reason there would be that because we rounded both the numbers up, it's given us a bigger number when we worked out this 8,000. So 8,000 was more than it should have been. So therefore it's an overestimate. And there we go, there's a bit of estimating.
For the first one, we've got work out 3 4/5, add 3/7, and give your answer as a mixed number in its simplest form. Now when we're looking at this sort of question here, one thing that we need to remember, no matter which type of calculation we're doing, adding, subtracting, dividing or multiplying, if we have mixed numbers involved, we need to make them top heavy first. Now when it comes to adding and subtracting, there is a little bit of a different approach that you can take that some of you may use, but I'm going to use the same method for all of these types of questions, and that is making any mixed numbers top heavy fractions first, or improper fractions first. So the process for doing that is obviously taking our fraction here, 3 4/5, we want to turn that into an amount of fifths. So to do that, we want to figure out how many fifths are in 3. So we can do 3 times 5, which is 15. Add the extra 4/5 there, and that makes 19 fifths. So 3 4/5, 3 times 5 is 15. Add the 4 that we've got there as well is 19 fifths. Okay, so it's the big number times the bottom to make 15, add the top number on the fraction there, 19, so we've got 19 fifths. And we're going to add that to the 3/7. Now when it comes to adding and subtracting, we need to have a common denominator. So we need that number on the bottom to be exactly the same. Now that means that we can multiply both fractions here. As long as we do whatever we do to the bottom, we also do to the top. We can make equivalent fractions with a common denominator. So thinking about 5 and 7, the lowest common multiple of those is 35. So in order to get them to be 35, the left fraction there, I can times the top and bottom by 7. And the right fraction we can times the top and bottom by 5, and that would give us 35 on the bottom of both. So we've still got to work out 19 times 7 there, and obviously take your time doing so, but 19 times 7 is 133, and at the moment that is going to be over now 35. Okay, so you get some quite big numbers here, but obviously don't be afraid just to the side to do some multiplication there. I did 7 times 10, and 7 times 9, and added them both together, okay, but you can show you working out to the side. On the right fraction there, we're going to times them both by 5, so 3 becomes 15, and 7 becomes 35. And now we're in a position where we can add these both together. So we can just add together the numerators, 133 plus 15, which gives us 148, and that is over 35, remembering that you don't add together the denominators. There we go, we've got 148 35ths. Now obviously it says here to give your answer as a mixed number in its simplest form. So it's up to you whether you try and simplify this or whether you so obviously turn it into a mixed number first, but we need to turn it back into a mixed number. So to do that I need to know how many times does 35 go into 148. That's not the nicest, so I'm just going to write down a few of the 35 times table. So 35, add another 35 is 70, add another 35 is 105, add another 35 is 140, and then it's not going to go beyond 140 there, because obviously our number there is only 148. So to go from here, we know that 35 goes in 4 times, so that's going to be a big 4. And what's left over from 140 to 148 is an additional 8 35ths. There we go, so 4 and 8 35ths left over. Okay, so looking at that number there, you've just got to decide as well, does that little fraction at the end there simplify? Does 8 over 35 simplify? Now in the case of this fraction here, it actually doesn't. There's nothing that goes into both 8 and 35 other than 1, and obviously that's not going to simplify it for us. So that actually is fully simplified there. So even though it says give it in its simplest form, in this circumstance here, that little fraction on the end there doesn't simplify, okay? But it's going to say that anyway, because we didn't have to use 35 as our denominator. We could have potentially used a bigger number like 70 or even larger if we wanted, but because we used the lowest common multiple, it's just ended up that doesn't actually simplify at the end there. But do look out for that, because that fraction quite often does need simplifying, okay? But there's our final answer, 4 and 8 over 35. Let's have a look at some subtracting. Right, okay, so this question says 2 and 1/7 take away 1 1/4. Okay, work that out and give your answer in its simplest form. Now it doesn't mention anything about it being a mixed number, so that obviously gives us a bit of a hint that we're not going to have a mixed number here. We're just going to go about this process in exactly the same way as when we were adding, okay? Adding and subtracting, the process is the same, except obviously we're not going to add our fractions together at the end, we're going to take them away from each other. So we're going to make them top heavy to start with, turn them into improper fractions. So 2 and 1/7, 2 times 7 is 14, add the 1 is 15 over 7. And the 1 on the right, I'm obviously taking these away. 1 times the 4 is 4, add the extra 1 on top there is 5/4. There we go. We just need to make these have a common denominator. And again, we'll look for the lowest common multiple here. So 7 times 4 is 28. That does actually give us the lowest common multiple there. So we're going to make the denominators out of 28. So we're going to times the right fraction by 7. Okay, that's top and bottom. And we're going to times the left fraction by 4. And again, that's going to be top and bottom. So our two fractions are going to be out of 28, so I'm just going to write two blank fractions here. I know what the denominators are going to be. I just need to figure out those numerators. So 4 times 15 on the top of the left one gives us 60. And 5 times 7 on the top of the right one gives us 35. There we go. So we've got 60 over 28, take away 35 over 28. So again, the denominator isn't going to change. We're just going to write how many 28s we have left. But 60 take away 35 there leaves us with 25. There we go, so that is our final answer there. We get 25 over 28, sorry. Okay, so again, just having a quick look, does that simplify? Are there any numbers that go into 25 and 28? No. Okay, 25 divides by 5, 1 and 25, and none of those apart from 1 obviously go into 28, so it doesn't simplify. So again, it says give your answer in its simplest form, but again, we got the lowest common multiple there for the denominator and made sure that they're the ones we use. So a little hint for you there is always look for that lowest common multiple, okay? In the case of these two, they were quite nice because it was just the two denominators times together, but you always want to have a look for that lowest common multiple just to avoid having to do that simplifying at the end there. For this one, we are going to work out 3/5 of 65. So again, just like before, to start with, we are going to work out 1/5. So to get 1/5, we're going to divide by 5. So for 1/5, we're going to do 65 divided by the denominator there, which is 5. And again, if you're not sure on that, just do some division to the side. You might know how to do that mentally if you want, but 5 goes into 6 once, remainder 1, and into 15 3 times. So there we go, the answer is 13. So 65 divided by 5 is 13, and that's 1/5. And then again, flipping to the numerator because we want 3 of those. So we're going to times that by 3. So for 3/5, we are going to take the 13, multiply it by 3, and that gives us an answer 39. And again, you can do your working out to the side if you need to for any of those. But there we go, that's how we're going to work out a fraction of an amount. So divide by the denominator to get one of them, whatever that denominator may be, and then multiply by the numerator, and that's going to give us our answer for working out whatever fraction we're looking for, whether it be 2/7, 4/9, 3/11, whatever it would be. So divide by the denominator and then multiply by the numerator. Okay, so this question says 3/5 of a number is 48, work out the number. So this really tends to confuse people when it does come up, because obviously when you see 3/5 of a number, a lot of people are going to think, okay, straight away divide by the bottom times by the top. But this is actually in reverse. This is saying that 3/5 of a number is already 48. And if we think about this in terms of our bar again, let's just think about if we had split this up into 5 portions this time, because it is in terms of fifths. There we go. So if I split this up into 5 parts, which I may not get perfect, there we go, good enough. And it's what it's saying is that 3 of them has already been calculated as 48. And we want to know what the entire original number is.
So looking at this then, okay, well, if only 3 of them were 48, well, we wouldn't divide by 5 anymore, but instead we would divide by 3, because we want to know how much is going to go into each of those 3 boxes just above. So this time, and it's obviously the complete reverse of before, because this time we're going to divide by that numerator. So instead we're going to divide it by 3, and that's going to tell us what number goes into each of the bars above. So 48 divided by 3 is equal to 16, and again you can put that, obviously the working out, just to the side. So if I put now 16 into each of these bars, I would also put it into those additional 2, because we are looking at now all 5 of them. So that number there, if we add up all of those 16s, and again you can obviously add them all up, or you can do 16 multiplied by 5. So that working out I would do to the side, 16 times 5, because there are 5 boxes, and that adds up to 80. There we go, and that is my answer. And again, you could put the 80 next to your diagram if you prefer to use a diagram method, but that is how we're going to go about approaching these questions. So if you think about what we've actually done, it's just the complete opposite of what we did before, and that's why it's in reverse. This time instead we are dividing by the numerator and multiplying by the denominator. But you need to understand why, and I think that this visual idea really does help you to understand why we would divide this time by the numerator and why previously we were dividing by the denominator. Okay, so this is a bit of a special one. It says write down the value of 3 squared times 3 cubed all over 3 to the power of 5. Let's just have a look what we get here. So if we tidy up the top, adding the powers, we get 3 to the power of 5 on the top. And that's also being divided then by 3 to the power of 5 on the bottom. Now it says write down the value. If I think about what this is as a power of 3 though, if it's a power of 3, 3 to the power of 5 divided by 3 to the power of 5, we subtract the powers. So that's 5 take away 5, and 5 take away 5 is 0. So 3 to the power of 5 take away 3 to the power of 5 gives me 3 to the power of 0. Now 3 to the power of 0 here is a special one when we've got something to the power of 0, because if we think about what we've actually got here, we've got a number on the top and it's being divided by the same number on the bottom. And what happens when you divide any number by itself? Let's just think of an easy number, just 3 on its own. 3 divided by 3 gives us the answer 1. Anything divided by itself equals 1. So therefore 3 to the power of 0 must equal 1. Okay, and this rule applies for everything here when we've got something to the power of 0. Anything to the power of 0 is going to equal 1. It doesn't matter what I pick, whether I pick 5 to the power of 0, that's going to equal 1. I could pick anything, 49 to the power of 0, that also equals 1. Okay, just thinking about this logic here of anything divided by itself has to equal 1, and that's how we get a power of 0. So I'm not going to give you any questions on this, but it's another little rule to have a bit of a think about. If you are asked to find something to the power of 0, the answer is always 1. And just be careful not to mistake that power of 0 as a degree symbol. It's not, it's a power of 0 there. Okay, so write down the value of 4 to the power of negative 2. Now the negative part's still going to do the same thing, so we're still going to do the reciprocal. So 4 again is not a fraction, so we'll write it as 4 over 1, and the reciprocal of that is 1 over 4. Now this actually has a negative 2 in there, so that 2 is just a normal power. Okay, so the 2 is just a normal power of 2, and when we do a power of 2 we square what we've got. So when we're squaring a fraction, we are just going to square it like we would a normal number, except we're going to square the top and we're going to square the bottom. So the square of 1, 1 squared, 1 times 1 is still 1, and the square of 4, 4 times 4 is 16. So there's our final answer, 1 over 16. So a negative power flips it over, the number is just a normal power. Right, so write down the value of 125 to the power of a third. So again, 125 to the power of a third. We have this number on the bottom, which is the root, and a 3 would represent a cube root. Again, it's just a 1 on the top though, which is a normal power of 1, and a normal power of 1 does not change our number at all, so a normal power. But a cube root, let's write that in, so that would represent the cube root of 125. So it does help to know your square and cube numbers here. 125 is a cube number, and the cube root of 5 is 5. There we go. Remember, you can always think about that backwards. You can think, okay, well, 5 times 5 is 25, times 5 again is 125, so the cube root of 125 is 5. So when you're doing these fractional powers, just look at what number's on the bottom. That could be a square root, a cube root. We could have a 4 on the bottom, and that would be a 4th root. We could even have a 5 or numbers beyond. Okay, so a bigger number here, 504,000 in standard form. So there isn't a decimal in this number at the moment, but the decimal would be here at the end if we had one.
So if we think about where that decimal would be if we were to write it, to write this in standard form, we'd have to do quite a few hops here. So 1, 2, 3, 4, 5. Okay, so that's 5 hops for this number. And that would make the number 5.04. Okay, not forgetting that that 4 exists, we can't just not include that, it's still there. So 5.04, still times 10, and that was 5 hops. It's a big number, so 5. Okay, not a negative power for this one because it's not a 0-point number, it's a large number. So 5.04 times 10 to the power of 5. So just remember, if it's a large number, you're going to have a positive power with however many hops you've done to make it between 1 and 10. And if it's a 0-point number, you're going to have a negative power again for however many hops you've done to make that number between 1 and 10. Okay, 8.03 times 10 to the minus 5. So it's a negative 5 there in the power, so it's going to be a 0-point number. So I'm going to have to hop it the other way this time. So let's write out what we've got so far. We've got 8.03. So the decimal is already drawn in for us, it's just in there. So we're going to hop it from there to the left to make sure it's that 0-point number because it's a negative 5 as the power. And we're going to do 5 hops. So 1, 2, 3, 4, 5. And then let's fill in these zeros and put that decimal in there where it's going to go now. Now we've got this number here. Obviously we just need to tidy this up because we would normally write this with a 0 at the front. So tidy that up with a 0. And let's rewrite actually what we've got here. So we've got 0.0000 and then 803, and that is my final answer there for writing that as an ordinary number. So just remember, if it's a positive power, we're going to hop it to the right to make sure it's a big number, and if it's a negative power, we're going to hop it to the left to make sure it's a 0-point number, a little number there. Okay, so looking at this one, 4 times 10 to the 5 times 3 times 10 to the minus 2, and there's an example of one where we probably wouldn't want to write this out as ordinary numbers and work them out because it might get a little bit overcomplicated here. But let's look at applying that same little trick. So let's do the 4 times the 3, which gives us 12, and that's going to be times 10 to the power of something. I've just got to be a little bit careful here because although we can add these powers, let's just have a look because one of them's a negative. So the powers, if I write this to the side, we're going to do 5, the first power, and we're going to add the next power, which is negative 2. And 5 plus negative 2 is 5 take away 2, so my power there is going to be 3. So that's fine, 12 times 10 to the power of 3. And again, we just need to put this in standard form because this 12 is not between 1 and 10. So instead we'll make that one jump smaller, we'll make it 1.2, and to balance that out we'll make the power one jump bigger, so 3 goes up to 4. And there's our final answer, 1.2 times 10 to the 4. One more question before we have a go. So 4.3 times 10 to the minus 5 times 3 times 10 squared, again giving your answer in standard form. So we can apply the same little trick again. We've got 4.3 times 3. If you've not got a calculator here, we could just add together 3 4.3s. We're timesing it by 3, so 4.3, 4.3, and another 4.3, 3, 6, 9, and then 4, 8, 12. So we get 12.9. So 4.3 times 3 is 12.9. Times 10, and let's figure out what that power is going to be. So that first power is negative 5, and we're going to add 2 to that. So negative 5 add 2 is negative 3. So my power there is going to be negative 3. Again, it's not in standard form though, so I'm going to have to balance it out. So I'm going to make the number one jump smaller, down to 1.29. I'm going to make the power one jump bigger. So bigger than negative 3 is negative 2, getting closer to 0 there. So there's our final answer. Just following the same process, building it up in difficulty, we did 4.3 times 3. I used a little bit of working out to the side, which is absolutely fine to do. Then we balanced it out, so we made the number at the start one place value smaller, balanced it with making the power one jump bigger. Just watch out there when it is a negative power there, making it one bigger would not go down to negative 4, that would be going smaller, so we are going up to negative 2 to make it bigger. Okay, so in this question we just need to put some symbols in the correct boxes. So it says here are the symbols, and we have the less than symbol, the greater than symbol, and the equal to symbol. Write one of these symbols in each box to make the 4 true statements. So 14 is less than 21, so we can put the less than symbol in there, that one's okay. Now this one here we're going to have to work out, so 4 plus 7 is equal to 11, and 103 take away 92, well that is also equal to 11. So that statement there, they are equal to one another. For the next one we've got 2 squared, 2 times 2 is 4, and here 2 times 2 is 4 as well, so again that's equal to one another. And then for our final one, negative 3 and negative 5. Well, negative 3 is greater than negative 5, it's closer to 0, so it's a bigger number.
And there we go, there is filling in symbols where we're using inequalities. Okay, so when we're looking at some systematic listing, it says here Jennifer's going to have a meal. She can choose one starter and one main course, and then we've got our three options for the starter: pate, melon or ham. And for the main course, let's just highlight that in a different colour, we've got beef, salmon or lasagna. So it says write down all the possible combinations Jennifer can choose. And that word systematic listing means we're going to make a list in a system or a systematic way. That means quite basically a logical way. We're going to use a system to create it. So we're going to start off by picking the first starter, and I'm just going to use the first letters, and let's just check to make sure they are all different letters. Yes, they are. So for the pate as the starter, we would then have a main course of beef, or we could have the pate starter with a main course of salmon, or we could have the pate starter with a main course of lasagna. So the system that I'm using is I'm starting with the first starter and matching it up with all the main courses. Now that I've matched it up with all the main courses, I would go on to the next starter, which is the melon. And again, I'm just going to match that to all the same main courses above. So melon with beef, melon with salmon, and melon with lasagna. And then I'll go on to the final one, which was ham. So ham and beef, ham and salmon, and ham and lasagna. And that is all of our possible combinations there, and that is completed. So we've used a nice system to create this list. Okay, so that's how we go about using systematic listing. Okay, so when looking at some length conversions, we need to remember for this first one where it says to change 450 centimetres into metres, how many centimetres are in 1 metre? So there are 450 here that we need to convert. Now in each metre there are 100 centimetres, so we've definitely got more than 1 metre here, but we could actually just divide it by 100. If you can't just spot this answer, divide it by 100, that would hop the decimal to here, and that'd be 4.5. So for this one here, we would say 4.5 metres, and that would be our first answer. For the next one, we're going from metres to millimetres. That's quite a big conversion there. So to start with, rather than jumping straight from metres to millimetres, let's go back from metres to centimetres. So 9.4 metres, if we want to turn that into an amount of centimetres, again, we'll just do the opposite of what we've just done, which is multiplying by 100. So if we hop the decimal over twice, that would be 940 centimetres. Now this next conversion relies on you knowing how many millimetres are in a centimetre. Of course, if you have a ruler, that's quite nice and easy to remember because you can look at your ruler. But there are 10 millimetres in every 1 centimetre. So we would times that by 10, and that would turn it into millimetres. So that would be 9,400 millimetres. Now, of course, you might have spotted there, if we are timesing by 100 and then timesing by 10, then we could have actually just multiplied by 1,000, but that's going to give you a lot of conversions that you need to remember. So I would prefer to just remember the conversion between metres and centimetres, and then also centimetres to millimetres. But there we go, that's how we go about some length conversions. Now when it comes to all of these percentages, my first step is always the same, and that is to work out 10%. So to start with here, we're going to write down what 10% is. So 10% is nice and easy for us to find. You take the number, which in this case is 80, and you just divide it by 10. And that just means essentially you can do your little trick, which is to hop the decimal in. So if you hop the decimal in over the 0, you get that 10% is equal to 8, which is always very nice when it does end in a 0. Because obviously you can apply the trick, which is just to get rid of the 0 there. But 10% is 8, and now we need to figure out how we're going to get to 35%. Now because there's a 5% in there as well, we're also going to have to find a 5%. And that's easy enough now that we have 10%, because we can just halve 8, and that would give us that 5% is equal to 4. We now have everything we need in order to build up to 35%. We know that 10% is 8, so if we want to get to 30%, we would want to have 3 of those, and the additional 5% there, which would get that up to 35% in total. So you can apply different methods here in order to get to 35%. You could either just add together the pieces that you need, or you could do some multiplication as well. And what's a nice easy method that you can do is just say, okay, we want 3 of the 10%, so 8, another 8, another 8, and a 5%, which is a 4, and just add them all together. Okay, you might argue actually it's a bit easier just to times 8 by 3, but we get 8, 16, 24, plus the 4 is 28. And that would be our final answer, 28. So there we go, nice and easy. Okay, so this question here then, we've got a lot of information. It says, on Saturday, some adults and some children were in a cinema. It says the ratio of the number of adults to the number of children was 5:2. And each person had a seat in standard seating or had a seat in the premium seats. 3/4 of the children had a seat in the premium seats and 117 children had a seat in the standard seats. And there are exactly 2,600 seats in the cinema. Let's just highlight that in a different colour. And it says on the Saturday, were there people on more than 60% of the seats? So there's a couple of different ways that you could approach this. What we could do is we could straight away work out that 60%, which seems a little bit counterintuitive as it's the last line in the question. But if we work out that 60% straight away, we'll know what kind of number we're aiming for here. So we could work out that 60%. And again, depending on whether you are using a calculator or not will depend on how you approach that. But if we do that without a calculator, because that's relatively simple for us to do, we can just work out this 60% to start with. So 10% would equal 260, and then we times that by 6 to get our 60%. And if we just do that using column multiplication, just to get our answer nice and quick, 6 times 0 is 0, 6 times 6 is 36, and 6 times 2 is 12, so that's 1,560. Now on a question like this, you never know in an exam, that may have just got you a mark. So well worth working that out if that's the nice easy step to go for this question. So let's get rid of that, and obviously always leave your working out again, but we'll get rid of that and we'll just have a look at going back to the start. So it says adults to children was 5:2, and then it gives us some information about where they sat. We know that 3/4 of them had seats in the premium seats and 117 children were in the standard seats. Now both of those bits of information are just about the children. So if 3/4 of them were in the premium seats, the other quarter must have been in the standard seats. And it tells us that that was 117 children. So we'll know if this one is 3/4 and this one was 1/4, because it's the rest of the children, and it tells us that that 1/4 is equal to 117. We just want to know what the 3/4 is equal to. And we know if 1/4 is 117, in order to get 3/4, we'd just have to multiply that by 3. So if we multiply that by 3, that is going to tell us the amount of children that were in the premium seats. So 117 times 3, and again you've just got to do some working out. Again, you can either multiply it by 3, or you could just add that together 3 times, whichever you prefer. I'm going to use a combination of methods here. So that adds up to 21, that adds up to 5, and that adds up to 3. So that is 351. So we know that there are 351 children that are in the premium seats. Let's get rid of that working out because we now have quite a lot of information. We know that the first thing we worked out, we start trying to see if they filled 1,560 seats. And now in this second bit of information, we've actually worked out the total number of children. We have 351 that are in the premium seats and 117 that are in the standard seats. So if we add those both together, we have 8, 6 and 4, so 468 children. Now we obviously just want to work out how many adults there are. So we know that there are 468 children, but how are we going to get to the adults? So it tells us the ratio of adults to children at the start, just over here, and it tells us that the ratio of adults to children is 5:2. And we've already worked out that the children in that ratio is 468. So we're using a different part of our ratio here. We're not just sharing in a ratio, we're actually working backwards because we've already been given one of the numbers. So in order to get back to one part, we could divide that by 2. And that would allow us to then figure out the other way around what we would have to have multiplied by, and essentially to get our number down here to figure out the amount of adults. So if I want to work that out to the side, I can do 468 divided by 2, which tells me what one part would be worth, and that answer comes out as 234. So we must have multiplied by 234 per part in order to share that ratio out. So times 234. So that means in order to get the total amount of adults, we're going to have to times by 234. Again, if this is non-calculator, you're going to have to do some working out there. Or you could just apply a little bit of a trick for timesing by 5, which is to times by 10 and halve it. Although you might argue it's probably just quicker to do 234 times 5 to the side and just get that correct. So 5 times 4 is 20, 3 times 5 is 15, add the 2 is 17, and then 2 times 5 is 10, plus the 1 is 11. So in terms of working this out, and we're going to need a bit more space there, so let's get rid of that arrow, we've got 1,170 adults. And to get there, we times by 234. Okay, so we've got quite a bit of information now. We've got 1,170 adults, and we've got 468 children. And it said, is 60% of the seats filled? And we already worked out that in order to fill that, we needed to fill 1,560 seats. So now we have all this information, and let's get all of this out of the way. We can actually finish this question off, because we can actually just add these two together, and that's going to give us the total amount of people at the cinema. So to finish this off, we do 1,170, the total amount of adults, add 468, the total amount of children. That adds up to 1,638, which is greater than 1,560. So where it says were there people on more than 60% of the seats, we would say yes, and you could either then write a sentence to say 1,638 is more than 1,560, or you could just say it as an inequality, 1,638 is greater than 1,560. And there we go. And don't forget to write your conclusion here, as it does say that. And don't forget the question does say you must show how you get your answer. So all of that working out is essential. So this question on the screen here, it says only blue vans and white vans are made in a factory. It says the ratio of the number of blue vans to the number of white vans is 4:3. And it says for the blue vans, the number of small vans to the number of large vans is 3:5. Work out the fraction of the number of vans made in the factory that are blue and large. Okay, so we're looking at these ones that are blue and large. Now, as this sort of question develops and this sort of gets a little bit harder, there's a specific approach that I'm going to take when I'm actually looking at these. And that is I'm going to kind of structure this in the same way that you would structure a probability tree, and looking at this as more along the lines of work out the probability of picking a van that's blue and large out of all of these sort of vans in the factory. And the sort of way that I'm going to draw this then is I'm going to draw a bit of a probability tree. So I'm going to start by saying blue to white. Okay, so we've got the vans, they're blue or they're white. Now over here we've got the ratio of blue and white, we've got 4:3. Now that's out of 7 in total. So 4 out of the 7 there are blue and 3 out of the 7 there are white. So for the blue here we've got 4 out of 7. And for the white here, we've got 3 out of 7. There we go. And then it gives us the next piece of information. Now, it only mentions anything to do with the blue vans here. And as these sort of questions develop, we're going to have a look at ones where it mentions something about both branches here. But in this particular question, look, it just says for the blue vans, we've got small and large. So we're only going to do another branch coming off the blue vans here. And that's going to be our small ones and our large ones. And again, we've got a ratio here, it's 3:5, so it's out of 8 in total. So for the small vans there, that's the 3, and that's 3 out of 8. And for the large vans there, it's 5, and again, that's 5 out of 8. Now, when it comes to actually working out the fraction here that are blue and large, we treat it in the same way that we do a probability tree. We have a look, okay, we go up the blue branch, and we get 4 out of 7 for the blue. And then we go up the large route or down the large route, depending on how you've drawn it here, and that's 5 out of 8. Okay, and just double check that you've put those in the right place. That's large, 5 out of 8, that's right. So that's blue and large. So all we do normally when we're going along a tree like this is we just multiply those fractions together, and we're not going to do anything different in this question. So all we're going to do is we're going to take that first fraction there for blue, which is 4/7, and I'm going to multiply it by the large fraction there, which is 5/8. There we go. And multiplying fractions is nice and easy. We just times the top and times the bottom. So 4 times 5 is 20. And 7 times 8 on the bottom is 56. There we go, and that's our final answer. 20 out of 56 is our fraction of the vans in the factory here that are blue and large. Okay, so hopefully that makes it quite nice and simple to understand, but essentially we just pair together the two fractions that we're looking at and multiply them together just like we would on a probability tree. Okay, so looking at a money problem. It says here Carla is planning a holiday for 4 people for 7 days. Here are the costs of the holiday for each person. So the travel is £150, the hotel is £50 for each day, and the spending money £250. Work out the total cost of the holiday for 4 people for 7 days. So let's work out each person to start with. Once we've got the cost for one person, we can just times that by 4 as there are 4 people. So we've got the £150 is on the travel, so we know that that's going to be £150. The next one, we've got £50 spending money, or sorry, £50 for the hotel for each day. So if we're going for 7 days, 50 times 7, well, 5 times 7 is 35. So 50 times 7 would be 350. And of course, you can work that out to the side using column multiplication or whatever method you prefer. And then we've also got the spending money. It doesn't say that's for each day, so we'll assume that that's just the spending money for the whole trip. And then if we add all of those together, that's going to be the total cost per person. So we have 0, 15 to carry the 1, and then 3, 4, 5, 6, 7. So £750 per person. Now, of course, we've got 4 people, so we'd do 4 lots of 750. You could always just add together 4 of them, or just use some multiplication. 4 times 0, 4 times 5 is 20, and 4 times 7 is 28, plus the 2 is 30. So that's £3,000. So the total cost for the holiday for 4 people for 7 days is £3,000, and there's our final answer. Okay, let's have a look at our next question. Okay, so looking at a bit of density without using a calculator. Now, when we've got density in a question, straight away we want to write down our formula, or you could write down a formula triangle. So I'll write down a formula triangle. Density is equal to mass over volume. So if we put that in a formula triangle, we can obviously work out any of them just by covering one of them up. So it says a lead pipe has a volume of 40 and the density of lead is 11.3 grams per centimetre cubed. Now, as soon as you see that, particularly this is a non-calculator question, it's going to put a lot of people off because we've got decimals involved. We know we're going to have to do a multiplication or potentially a division. But it says work out the mass of the lead pipe. So if we cover up the mass on the top there, we know that to work out mass, it's density times volume. So to work this out, we need to do 11.3 and we need to multiply it by 40. Now, that obviously doesn't look very nice, but on its own, that's not a particularly difficult question. All we'd need to do, and there are other methods of going about this, you could do things like multiplying by 4 and adding the 0 on if you're happy to do that. But no matter what the number here, if we just hop the decimal out, if obviously you had a decimal here, we'd have 113 multiplied by 40. We'll work that out, hop the decimal back in, and we've got our answer. So 0 times all of those is going to be 0, so we'll just put 0 for all of that. Then we've got our placeholder because we're moving on to the tens. 4 times 3 is 12, carry the 1. 4 times 1 is 4, plus the 1 is 5, and then 4 times 1 is 4 again. So we have 4,520. Obviously, we just need to hop that decimal back in. So if we hop it back in, we get 452.0. It's going to show there that I've put that back in. So our answer would be 452. Now, of course, we're looking at a mass, so we need to give a unit of mass, and we can always find that unit of mass within the question. This particular question gave it us in the density units there. It said grams per centimetre cubed, so that would be 452 grams, and that would be our final answer for that question. So don't be put off by these sorts of questions where they normally appear on a calculator paper. Just follow that same process and remember your written methods. Okay, so solving 4x plus 2 all over 5 equals 6. Now, same process again, it's all locked in by this denominator, which is dividing by 5. So the first thing I'm going to do is times both sides by 5 to remove that divide. Now again, it's not going to change the top there, we're just removing a divide. So 4x plus 2 equals 6 times 5, which is 30. And now, as you can see, it looks very similar to the question that we had before. We're just going to follow the same approach now to solve it. So it's a plus 2, so we're going to minus 2. So take away 2 from both sides, and we get 4x equals 28. And then just like before, dividing it by 4, and that gives us x equals 7. There we go, and there's our final answer. For this one, we've got 9x minus 5 equals 3x plus 13. Again here, 3x is the smaller value of x, so I'm going to subtract 3x on both sides of the equation again. Taking away 3x would leave us with 6x over here, minus 5, and that equals positive 13, so I'll just write 13. Again then, moving the numbers to the other side, it's a minus 5, so we're going to have to add 5. And we get 6x equals 18. And this is quite a nice one here, because 6 does go into 18, so when we divide by 6, we get x equals 3. We don't have to worry about any fractions there and simplifying those. Okay, so when looking at recognising graphs, this isn't really one of those ones where you can just teach it on one question. To do this and to know this properly, you need to have looked at straight line graphs, quadratic graphs, reciprocal graphs, cubic graphs as well, and you need to just be able to recognise what they look like when you were learning them, when you were doing them. But for this question here, we'll have a look anyway. So it says our first one here, we're going to match up each of these graphs in the table and put the letter. Now we have two linear graphs, these two here. We've got one with a positive gradient and one with a negative gradient. So we'll start with those two. Now in our equations here, the first one has an x squared, so that is a quadratic graph. The next one is a linear graph, so we'll have a look at that one. The next one's a linear graph as well, and then we have a reciprocal graph down here where there is a division with x. So we're looking at these middle two. Now let's look at the gradients for those. Now the first one, we've got y equals 3 minus 2x, so the gradient of that is negative 2, that number, that coefficient that's stuck on the x. So that one's our negative gradient, so that's going to be graph D, as that's going to be sloping downwards. And our next one has a positive gradient, you can see that's 2x plus 3, so positive 2, a positive gradient, and that'll be graph A. And this is exactly how I'd approach this question anyway. I would pick the one that you're most familiar with. You might disagree and say, actually I knew straight away which one the quadratic was, and that's fine, you could have done that one first, but always work from the one you know to the one you're not so sure on. So for this one here then, the first one, which we've already highlighted, the x squared minus 7 is a quadratic graph. So that is graph B. Quadratic graphs have this U shape, or if it's a negative quadratic, a negative x squared, it has an N shape. But you're probably only going to be looking at these U-shaped graphs anyway. But of course you need to remember that in case there is a negative x squared as well. Now again, you can see that that is correct for this graph because the y-intercept, that number at the end, is negative 7. So that matches up just down there with our negative 7. So that would be fine as well. So we're happy with that. That is graph B. And for our final one, process of elimination, we have our reciprocal graph, and that is graph C, and that is obviously this one just here. So that reciprocal graph has a very unique shape, and obviously you just need to be aware of that when you are dividing by x. You get these reciprocal graphs here which never touch the axes, as when you're dividing by x you can never divide by 0, so it never ends up touching the axes. Okay, so that is recognizing graphs. So this first one says, on the grid, draw the graph of y equals 2x plus 1. Now there's lots of ways of doing this, but essentially it's just about understanding what this actual line equation means here. So we know, hopefully, that all line equations need to be in this form, y equals mx plus c. Okay, so y equals mx plus c. Again, in this line equation, m represents the gradient, which in our line equation here is the number 2, so we have a gradient of 2, and c at the end there represents the y-intercept, which for us here is positive 1, so we've got a y-intercept of positive 1. Now in terms of what that means the graph's going to look like, we know it's going to cross through positive 1 on the y-intercept, which is right here. There we go, I'll try and mark that on, there we go. So we know the line's going to go through this point. And all we have to do is figure out where all the rest of the coordinates are. Now in terms of y equals 2x plus 1, remember x and y relate to the x and y coordinates. So all that this equation actually means is to find the y coordinate, you do 2 times the x coordinate and add 1, or double the x coordinate and add 1. So all we need to do is actually pick some x coordinates. Now if you have a look on the graph, you can see there's lots of x coordinates here. We've got minus 1, 0, 1, 2, 3 and 4 at the end there. Okay, so all we have to actually do is pick them, double them and add 1, and that'll tell us where the corresponding y coordinate is. And we can do that using a little table. You don't have to use a table, but it just tidy it up a little bit if we just make a little table here. Sometimes you'll be given the table, but it's quite unlikely that you'll be given it. So we've got some x coordinates and we've got some y coordinates we need to find. Now for x, we've got starting at minus 1, and then it goes 0, and then we've got up to 4, so 1, 2, 3, 4. So if we start with negative 1, this one here, we need to double that and add 1. I'm going to just sub that into my little equation up there. So y equals 2x plus 1. So it's 2 lots of minus 1, 2 times minus 1, and then add 1. And if we double negative 1, we get negative 2. Add 1 to that, gives us negative 1. So our first y coordinate there is negative 1 as well. So minus 1, minus 1. And we can plot that if we want straight away. There it is, minus 1, minus 1. Moving on to the next one. What do we have for this next one? We have the x coordinate of 0. So if we just, without doing all the working out for all of these, let's double 0 is 0, and add 1 is
1. So 2 times 0 is 0, add 1 is 1. And if we carry on doing this for the next one, so when x is 1, double 1 is 2, and then add 1 is 3. So double 1 is 2, add 1 is 3. And you can start to see there's a little bit of a pattern emerging. Okay, between all of these points, if you have a look from -1 to 1, that is adding 2. From 1 to 3, that's also adding 2. So actually all we need to actually do is keep adding 2. So add 2 to 3 is 5, add 2 again is 7, and add 2 again is 9. And then we can go ahead and plot as many of these as we can. Obviously we can't do them all here because the graph's not big enough. But for the next one, let's have a look. 1 to 3 is there, and 2 and 5 is there. Okay, so they're all the points we can plot. We could actually only plot it up to this point here. But once we've done that, all we need to do is grab a pencil, grab a ruler, and join it up nice and straight all the way through the graph, unless it states otherwise. So with your ruler, nice straight line going all the way through and extending it up to the edge of the graph there. There you go, and that is your line. And it's always good practice just to label it. You don't have to, okay, but you could just label that as the line y equals 2x plus 1. It just helps if there are multiple graphs or multiple lines on the graph, but you don't have to label it unless you're asked to. Okay, but there you go, y equals 2x plus 1. There are other ways of drawing this, and it just comes to having an understanding of the equation there. So we already talked about one of them, the fact that it starts on the y-intercept at plus 1, and then the fact that it has a gradient of 2 just means that for every step across from a point on the line, so if we look at this as, I know it's 2 squares there, you've got to be careful of the scale, but that's 1 across going from 0 to 1, and if you have a look, it goes up from 1 to 3. There you go, so it has a rise there of going up 2 for every 1. And you can always draw this in, it's a way of understanding it as well, so it's 2 there, and 1 here. Every 1 across it goes up 2, and that's what a gradient of 2 actually means. It means for every 1 step across it goes up 2 steps, even though the scale's slightly different here. It's 1 in terms of the numbers across and 2 in terms of the numbers going up, and that is what a gradient of 2 actually represents. But its best bet is just to draw the little table out and then get all your numbers nice and neatly drawn in. Okay, so when looking at intersecting graphs, we're going to have a look at this particular one. This is always one that looks way more complicated than it should. So it says here, use the graph to solve these simultaneous equations. When you're solving simultaneous equations, normally you're finding that x and y value, and that x and y value relate to the coordinate where they cross over. And you can see on this graph here, we can actually see that coordinate just there. So normally, when we're looking at simultaneous equations, like this one here, we try and make the coefficients of x or y the same signs subtract, different signs add, or whatever process you use to do that. Now this particular one has already shown us the graph, so we don't have to draw them, we don't have to do it algebraically. All we literally have to do is read that coordinate. So we'll go down, we'll read our x coordinate first, so x equals -2, and then we'll read the y coordinate, so go along, and we get y equals 4. And there we go, and that is using the graph to solve it. Of course, you might be asked to write down the coordinates of the solutions, in which case you would write it as -2, 4. Just make sure you read the question. But if it says find the solutions, we would write x equals and y equals. Okay, of course, you could also have to draw linear graphs and actually do these yourself, but this is just intersecting graphs and understanding where the lines cross over is that solution. Okay, so in this question we are given a line already drawn on a graph, and it says write down the equation of the line. Now we know already that what the equation of a line is going to look like. It's in this format, y equals mx plus c. Again, that c being the y-intercept. Now we can see the y-intercept on the graph, it's over here, 5. So for starters, I can actually just draw that straight in. We can say c equals 5, and we can just put that in our line equation. So y equals mx plus 5. All we need to figure out is what the gradient is. Now if we have a look at this question, we've got to find some coordinates that we can actually see. So here's another coordinate that's on the line, 1, 3. Now if I want to find the gradient between these 2 points, all I have to do is draw a little right angled triangle in. So I can go across or down from this red point, but if I go across and then down, I'm just going to say how big the movement is there. So that's a movement of 1 there. And then that's going down 2, so I'm going to say that that's -2. Now the equation to get the gradient, there's 2 different ways that you can look at it. You can have a look at it, and it's just use this little triangle. It means the change in, so it's the change in the y coordinate over the change in the x coordinate, and it's sometimes referred to as rise over run. Okay, so you might know one of these two, but change in y over change in x, or rise over run. Now in this case, look, the change in the y coordinate is this movement here going down, it's -2, so that'll be on the top of my little fraction here, -2, and the run, or the change in x, is on the bottom there, is the 1 going across, so it's -2 over 1, and -2 divided by 1 is -2. Okay, so my gradient here is -2. So it's obviously sloping downwards, which is why it's got a negative gradient, but that's what our gradient actually is for this question here. So all I've got to do is put -2 in place of m, and we get y equals -2x plus 5. Obviously, thinking about that last question that we looked at, you could actually write that as 5 minus 2x, but you can write it in either way, it's absolutely fine to do so. Just a little side note, you can actually do these triangles as big as you want. If I picked some different coordinates, let's have a look, that one there, and this one here, for example, and if I was to go down instead and make a big triangle like this, let's have a look, my run there is 4, and my rise goes from 7 down to -1, which is a movement of -8. And if I did rise over run for this one, or the change in y over change in x, it would be -8 over 4, and -8 divided by 4 is -2. So you can do this however you like, okay, because it's a straight line, it doesn't actually matter where you do the gradient from, it's just you just need to draw it in, just read those numbers very, very carefully so you can get the correct gradient there. Okay, so using some formulae. So this one here says make Q the subject of, and then we have a formula to rearrange. So when making Q the subject, we need to get rid of that constant to start with, so we're going to get rid of this +7. We're going to do that by minusing 7 to the other side. So our first step would say P minus 7 is equal to 6q. Always write out your steps. Now we want q to be the subject, not 6q, so we're going to have to divide by 6 to get that 6 unstuck there from the q. So if we divide by 6, we'd have p minus 7 all divided by 6, and always write it as a fraction. We don't want any multiplication or division symbols in a formula, and that is going to be equal to q. And if you want, you can write that the other way around. You can write q is equal to p minus 7 over 6, but it's fine to leave that equals q on the right hand side. Now we've got part B. It says part B, using your answer to part A, find the value of q when p is equal to -11. So we've already got q is equal to, and then p minus 7 over 6. So all we need to do is substitute p is equal to -11 into our rearranged formula. So if we put that in, we've got -11 take away 7, and all divided by 6 will be equal to q. Well, let's simplify the top, -7 and -11, let's say that the right way around, -11 take away 7 would be equal to -18. And we're going to divide that by 6. 18 divided by 6 is 3, so -18 divided by 6 is going to be equal to -3. So q will equal -3, and that'll be our final answer there, substituting that in. So it says find the 20th term in the sequence, and it starts to give us the start of a sequence. And obviously what we could do is just see what it's going up by and keep writing it, but if we're trying to find the 50th or the 100th term, it's not a very efficient way of us doing that. So we're going to actually have a look at how we can use the nth term to find the answer to this. So first of all, we're going to actually find the nth term of this sequence. So to start with, we note that it goes up in 3s. So the start of our nth term is going to be 3n, which means it's related to the 3 times table. And obviously using our little trick, we can go backwards. So take away 3, and that gives us +1 here. So it's 3n plus 1. Now thinking about what that means, and I've mentioned it in the previous video, and that means the 3 times table but with 1 added on. Now if we want to find the 20th term in the sequence, all we actually really have to do is sub 20 into this expression here. So n is going to become 20, or 3 times 20, so obviously the 20th term in the 3 times table is 3 times 20. So if we do 3 times 20, so I'm going to sub that in, 3 lots of 20, but then we just need to add 1 to that. So 3 lots of 20 is 60, and add 1 to that gives us 61, and that's how we can find numbers in a sequence quite quickly there. Okay, so find the nth term, sub the number in, and then obviously just write down what that number in the sequence is. As a sequence has an nth term of 2n squared plus 5. Find the 10th term in the sequence. So obviously we've got a different nth term here. This is a quadratic sequence, but we're going to approach it in exactly the same way. Now it does have a little n squared there, but it's already given us the nth term, so we've not had to find the nth term of this sequence. It's just been given to us, and it does look a little bit different to the previous two, but we're just going to apply it in the same way. So if we want to find the 10th term, we just need to sub 10 in. So if we sub 10 in, we've got two lots of 10 squared, n squared, 10 squared, and then add 5. Okay, so obviously remembering your order of operations here, you've got to work out the powers first, which is why I've put the 10 squared in the brackets, not to forget to work that out first. So 10 squared is 100. I'm just going to write that there. 10 squared is 100. So 2 times 100, working out this bit, would be 200, and then add 5 would give us 205. There you go. So a little bit of rules on substitution there. Obviously, don't forget to check out the video on substitution if that's thrown you at all, but just being careful to sub that number in. So we've sub 10 in place of the n, that's n squared, so 10 squared was 100, two lots of that is 200, and then add 5 at the end for 205. Okay, so this question says, is the number 51 in this sequence? Now again, we could keep writing and see if 51 appears, but we can actually just use the nth term again to actually figure out a question like this. Is the number 51 in the sequence? So if we find the nth term, okay, it goes up in 4s, so it's 4n, and then back 4 again, gets us -1, so 4n minus 1. Now there's our nth term. What we could do is we could just sub numbers in, see if we get 51, you know, sub 10 in, that'd be 40, take away 1 is 39, and just keep trialing and erroring it. But actually we can take a quick approach again. Now if we want to know if 51's ever in the sequence, we want to know, is there a number that I can sub into there that ever equals 51? And I can make that statement just by writing an equation. So I can just say, well, does 4n minus 1, does that ever equal 51? Okay, so does 4n minus 1 equal 51? And if we go about trying to solve this, let's see what we get. So if we add 1 to both sides, we get 4n equals 52. And then solving this just like a normal equation, divide by 4. So divide by 4, and we get n equals, and 52 divided by 4 is 13. There we go. So we get n equals 13. Now what we found out there is that if we sub the number 13 in place of n, that would give us 52. And you can go back and check it. 4 times 13 gives us 52. And then when you take away 1, you get the 51. So there we go. When we sub 13 in, we do get 51. So yes, we would say 51 is in the sequence, and we could even say it's the 13th term in the sequence there.
Okay, so looking at some parts of circles. It says here on the diagram below, draw a chord of the circle. Now a chord can be drawn in lots of different places, but we've got lots of different ways of drawing a chord as well, two specifically. Now you could draw a diameter. Okay, a diameter is a special name for a chord that passes through the centre. So you wouldn't be wrong to draw the diameter in. And of course, by doing that, I've already described to you what the diameter looks like. But a chord can be drawn anywhere as long as it touches 2 points on the circumference, and it's just a straight line. So we could draw it anywhere, it doesn't need to pass through the centre, and that right there would be a chord. You could also potentially be asked to draw something like a segment, and maybe it would ask you to shade that in. If you asked to draw a segment, that would just be this bit just here. You could shade that in as well. Obviously, if you were asked to draw a segment. As well as that, you could be asked to draw something like a sector. So you could use the radius and another radius to form a sector. So that's another piece that you could be asked to do as well. But of course, you are only asked to draw a chord. And our next one here asks you to draw a tangent. So a tangent is a straight line that touches the outside of the circle on the circumference at 1 point, and then keeps on going. So you've got to draw this nice and carefully. But there we go, that would be a tangent. So lots of different things that you could be asked to draw. We talked about the diameter, the radius, a segment, a sector, the chord, the diameter, obviously could be a chord as well, and now the tangent. So lots of different things that you could draw on a circle, but there we go. There are our two questions. Now for this question here, we've broken it up into two parts, and we're going to do them both on this one grid. And as you can see on the grid, we've got a triangle there drawn at this position here, obviously over in the positive section. Now when we translate a shape, what's going to happen is this triangle is going to move somewhere else. Now it doesn't necessarily have to go into any of the other sections, but it's going to move somewhere within this grid. So if we have a look at this first one to start with, it says translate the triangle by the vector, and then we have -4 on the top and 3 on the bottom. Now, if you don't have a very good understanding of vectors, there is a full video that I have done on column vectors, which I'll link in the description for you to have a go at. But in regards to this one, we're going to go through it relatively quickly. So that number on the top there represents going left or right. So a positive number moves it right, and if we have a look on the grid, look, the positive numbers go to the right and the negative numbers go to the left. So a positive number on the top indicates moving right and a negative number indicates moving left. And that goes for the same on the bottom, except the bottom number there is representing moving up and down. So again, positive numbers move it up and negative numbers move it down. Now the way to go about doing these is just to pick one of the corners or one of the vertices on the shape. I'm going to pick that top one there. I'm going to move that point 4 to the left, as we have -4 on the top, and I'm going to move it by 3 up. So let's move that. So we go 1, 2, 3, 4 to the left, and then 1, 2, 3 up, and that's going to finish off just there. Now, I would encourage you to draw these lines in, although you certainly don't have to. Obviously, if you do draw them in, just do them nice and lightly in pencil. Now I'm going to get rid of that, and we're going to draw it in from that point. Now just be careful, obviously, we're going to redraw it in from the point that we actually moved, so that top position of the triangle. So from there we need to go down by 2, again just keep looking at the triangle, it goes across by 1, so across 1, and then join it up. And obviously if the question says to label it with a letter or to shade it in or something like that, then obviously just make sure you do that as well. Now let's look at the next one. The next one's slightly different because it's going to move it slightly differently, because this time our vector says to move it 2 on the top and -4 on the bottom. So 2 on the top would indicate a movement of 2 to the right, and -4 on the bottom is 4 down. I'm going to pick a different corner this time. Let's go for this bottom right one. So 2 to the right, so that would be 1, 2, and then 4 down, so 1, 2, 3, 4. There we go, and let's just put a little cross there. And obviously this time then we're going to be drawing this particular triangle in from that bottom right corner. So we need to draw the base in to start with, up 2 for that triangle, and again joining it up, and again doing that nice and neatly with a pencil and a ruler ideally. Okay, so we've got a question here. It says, describe fully the single transformation that maps shape P onto shape Q. So we're going to go from the shape on the left to the shape on the right. Now the process is pretty much the same here, we just need to figure out how far it's actually moved. So let's match up some similar corners. So we've got this one on the top right, and we'll match it up to that one there. Now let's have a look how we get there. So from P to Q, so we'd have to go right, 1, 2, 3, so that's 3 to the right, and then 1 down. There we go, so 3 to the right and 1 down, and we could even put a -1 there, as we know that 1 down is going to be a minus. So in order to draw or write out our description here, we are going to have to state what kind of transformation it is. So we know that that is a translation. So we can say it's a translation, or we can also say it's been translated. So I'm going to write a translation. There we go, so a translation. And then in order to describe the movement, we give the vector. So I'm going to say a translation, I'm going to say by the vector, or you could say using the vector, or anything along those lines, and then we just need to write that vector in our bracket. So that's 3 to the right, so that's +3 on the top, and then 1 down, so that's -1 on the bottom. And there we go, that'll be full marks for us on that question. Alternatively with this question, obviously, you could be asked how to get from Q to P. That would have been slightly different, because actually to get from Q to P, we would have gone 3 to the left and we'd have gone 1 up. So it would have been pretty much the same vector, but the symbols in front of those numbers would be different. We'd have -3 and we'd have +1 if we were going in the other direction. So there we go, that's how we're going to describe a translation. It's very important that you include all of these words. You do need to say the word translation. The word moved is not going to get you the marks for this, because that's not the transformation. The transformation is called a translation. And we also do need to give that vector, and ideally stating that by the vector and actually then giving it. Okay, so working out the perimeter of a circle sector. Now it says A is the shape of a quarter circle of radius 15, and we can see that, work out an estimate for the perimeter of shape A. Now, quite a nasty one. So if we're going to start working this out, for starters, we've got the word estimate. So we're going to use pi is equal to 3. So pi is equal to 3 for this particular question. Now when we're working out the circumference, that's going to be part of the perimeter. So this little arc here, which is part of the circumference, as we just said, is one of the numbers that we need. So we need to think about our circumference formula. So the circumference is equal to pi times diameter. So for this particular circle, the radius is 15, so the diameter will equal 30. So to work out the full circumference, we would do the circumference is equal to pi is 3 times 30. So the circumference is equal to 90 centimetres. Now this is a quarter circle. So for just the length of that arc there, we're going to want to divide that by 4. So 90 divided by 4. Now you could write that as a fraction, 90 over 4, or you could start to simplify it, something like that. But if we were to write 90 divided by 4, that would come out as, well, we could halve it. We could get 45 divided by 2, and that is 22.5 centimetres. Okay, so not very nice there to get that particular length, but that there is 22.5 centimetres. Now to get the perimeter, we just need to add them all up. So we have the 15, we've got another 15 here for the radius, then we just need to add them all together. Of course, it did say to estimate, so we could have estimated 90 divided by 4. You could have rounded that up maybe, or I mean, you'd probably leave that as 90, but you could have maybe rounded 22.5 to 20, but I think that wasn't too bad there, dividing 90 by 4. So we'd probably have a range of answers for this if it was an actual estimate question, but we'll add these all together. You've got 15 plus 15 plus 22.5, and if we add those together, that's 30 plus 22.5, which is 52.5 centimetres, and that'd be our final answer just there. So obviously when it comes to circle sectors or looking at circles in general on a non-calculator paper, there's two different types of questions that you could have. You could have one like this where we're doing an estimate, or you could be asked to write things in terms of pi. So if we just think about another type of question that you could have here, for example, if we were asked to work out the area in terms of pi, what would we do? I'll leave that last line of working out there that we did for this question, but if we were to work out the area in terms of pi, what would we do? Now we would still use our area formula, so area is equal to pi r squared. And for this one here, obviously I'm making this up, so we'll have to think about the numbers as we go along, and then we'll have to divide our answer by 4. So we'll work out the area as if it was a full circle. So we would do pi times 15 squared. Now pi times 15 squared you'd have to work out to the side, that's 225. So we'd write the answer as 225 lots of pi. That's what doing it in terms of pi means, we just don't press times pi. So we've got 225, which would be the area of the full circle, but of course this is a quarter circle, so we'd have to divide that by 4, and because we are leaving it in terms of pi, and because 225 doesn't divide perfectly by 4, we'd just write it as a fraction over 4. Of course that might divide by 4, you know, if the number squared, for example, if it was 10 squared, and that was divided by 4, 100 divides by 4 quite nicely. So you could have 100 divided by 4, which would give you 25 pi. But this one in particular didn't divide by 4, so it'd be fine to leave it as a fraction. Of course, that's not what this particular question asked, but just a thought there if you had to write something in terms of pi as well. So it says that A to B to C is a straight line. So that tells us that these two angles next to each other have to add up to 180. So that's something we might use at some point. But it says work out the size of angle, and it gives us something different here. It says angle BDC. So to find angle BDC, you go from point B to point D and then down to point C. And you can see that by drawing that, it has created this angle just here. So that is the angle BDC, and that is the one we're actually going to be looking for. So again, you can obviously trace your finger over the shape to find that at any point. So let's think about that. We've got a triangle on the right there, this one just here, which is a scalene triangle. There are no lines on that particular one. There is a line just here, obviously because this triangle on the left is an isosceles, but that line there doesn't necessarily relate to the triangle on the right. So the triangle on the right is a scalene triangle, all the angles will be different or could be different, and on the left here we've got an isosceles. So because we have that top angle in the isosceles, we can definitely work out these two base angles. Again, just finding the ones underneath those two little lines. So at the moment there's a top angle of 70, so if we do 180 take away 70, it's going to tell us what's left to be split between the two base angles, and that is adding up to 110. So if we divide that by 2, that will split it into our base angles, and 110 divided by 2 is 55 degrees. So both those base angles are 55. Now that's going to allow us to move into the other shape. As we mentioned at the start, these two angles just here are going to add up to 180. So to find this angle just next to the 55, we would do 180 and take away 55. And that gives us an angle of, and again you can do your working out for this, but that gives us an angle of 125 degrees. So this one here is 125. And now you can see we have enough information on this right hand triangle to find our missing angle, because we now have two of the other angles. So if we add those two together, we've got 125 and 29. And if we add them up, that adds up to 14, 5 and 1, so 154 degrees. And we want to take that away from 180. So to finish this off, our final bit of working out, we'll do 180, take away 154. And again, if you can do these mentally, that's absolutely fine. But we'll just do our written method for the purpose of this video. 10 take away 4 is 6, 7 take away 5 is 2, and 1 take away 1 is 0. So that final angle there is 26 degrees, and that is the final answer for our question, because there we have found angle BDC. Okay, so here is our next question. It says here is a scale drawing of a garden. It says we need to plant a tree 5 meters from point C, nearer to AB than AD, and less than 3 meters from DC. Shade the region where we can plant the tree. So this time we've got 3 things to be aware of, and also we are going to shade a region rather than a point. Now if you do want to draw this out and you want to replicate it in the same size, I could just measure this rectangle for you, and as you can see it's 8.5 centimeters down, and if we want to go across, the rectangle is going to be, let's have a look, around about 13 centimeters across. So again, you don't have to draw this, but if you did want to follow along by drawing it, then you can absolutely do so. So we'll start with the first bit of information here, where it says we need to plant a tree 5 meters from point C. So if we're going to go from point C, then again we're going to draw a circle around point C. But it does say it wants it to be 5 meters. So we need to have a look at our scale, and as you can see down the bottom it says the scale is 1 centimeter is equal to 1 meter. So for 5 meters that is going to be 5 centimeters. So we just want to get our ruler and measure out our compass. So again, putting the compass point down at the bottom of the ruler and measuring out where 5 centimeters is. So 5 centimeters is only that far this time. So we'll put our compass point onto C, and we'll draw a nice circular arc that shows where it has to go. So there we go, that is going to be 5 meters from point C. So there we go, that's our first part. It now tells us that it has to be nearer to AB than to AD. So A to B is the line that goes across the top of the rectangle from A to B, and A to D is the line that goes downwards from A, obviously from A to D. So in order to do that, we need to do an angle bisector, because we're going to want to find the points that are closer to AB than to AD. So we need to bisect the angle in half so that we can see all of those points on that half. Now obviously this is a rectangle and not a square, so you wouldn't want to just join the point A to C, because that's not going to be a perfect angle bisector. So obviously watching the video on angle bisectors would be very helpful for this, but if you haven't watched the video on angle bisectors, I'll just explain it. So we go up to point A and we're going to put our compass on point A. And there are 2 ways to draw an angle bisector. I do it in one particular way, so I'm going to follow the process that I did on my video. So all we do is we take our compass and we're going to draw a nice arc that joins up the 2 lines, and we're going to draw a nice little arc like that, and then we just extend our compass slightly further and we're going to draw another arc, and there we go. And that's all we need our compass for, so we can put our compass out of the way now, as that's enough for us to draw our angle bisector. So if we move this out of the way, and we'll actually now join these up. So what we do at this point, so we do like what's called, well, what I call a crisscross. So I take the lower point of the first arc and join it to the higher point of the second arc, and then again the other lower point on the first arc and join it to the other higher point on the second arc. And where those lines cross over, that is going to be where our angle bisector needs to go from. So we go back to point A, and we're going to bisect the angle, and I'm going to extend that all the way to the end of the shape. And there we go, that has now split my rectangle into 2 halves in terms of closer to AB and closer to AD. Obviously we need to be closer to AB, so we're going to be above that line, obviously closer to the B point on the top right of the rectangle. Now we've got one more bit of information that we need to do, and that says that it needs to be less than 3 meters from DC. So in order to get less than 3 centimeters or meters from DC, we actually want to measure 3 centimeters above the line DC. I've said 3 centimeters because 3 meters would be 3 centimeters according to our scale. So if we put the ruler down the bottom of this side to start with, you can see where 3 centimeters is. And we just need to mark that up. And we're just going to put a little line here where 3 centimeters is. And then we're going to do it on the other side. So going over to the other side. And again, just marking that 3 centimeters so that we know where 3 centimeters up is on both sides. Now you would want to take your ruler and join those up nice and carefully. And we have a nice straight line. And again, mine's not going to be absolutely perfect. I probably could have done that a little bit better. So I'd go again. Oh dear, that's definitely not better. There we go. That's looking perfect. So there we go. There is our line. And above that is going to be greater than 3 meters from DC. And below that is going to be less than 3 meters from DC. So now we actually want to go about shading this position on the map here, or the scale drawing. So we need to plant it 5 meters from point C. And we need it to be nearer to AB than AD. And it has to be less than 3 meters from DC. So it has to be below that pink line. And it has to be closer to AB than AD. So if we think about where this is going to be, we know that it can't be above the line, so it can't be here, it can't be over here, it can't be over here, but it has to be below that. Now we know that it also can't be closer to AD, so any of these regions here below the blue line it can't be. It can't be this little one down here either. That only leaves us with 2. So we need to plant a tree 5 meters from point C. So if it has to be 5 meters from point C for whatever reason, that it can't be close to point C, it will have to be this little region here just in the middle. Otherwise it would be closer than 5 meters from point C, and it has to be at least 5 meters from point C. So that's the only region that it can be based on that bit of information, and that would be the final answer to that question. But as you can see, a question like this is pretty difficult because you've got all these construction lines all over the place, and you've got all these different bits of information. So you just need to go through them slowly, and crossing off some of the regions can be quite helpful. So obviously we've picked the easiest one to start with, which was that it had to be less than 3 meters from DC, or below that pink line, which allowed us to cross off a lot of those regions. And then obviously the fact that it had to be closer to AB than AD allowed us to cross off the ones down the bottom below the blue line, and that only left us with 2 then. So we just had to think about that first piece of information, which said that we need to plant it 5 meters from point C, which just meant that it had to be above or greater than that first arc that we drew when we drew a circle around C. So this question is slightly different, look, as we don't have an actual shape. We've got 3 points on a map. So we have the points A, B and C, and they kind of form this triangular shape. Now if you want to draw out again a sketch of this, again just try and draw this out to the same sort of size that it would be on a computer screen, but otherwise don't worry too much about actually getting this the exact same size. It says point T is 250 meters from point A, and then it says point T is equidistant from points B and point C. On the map show one of the possible positions for this point. So we've got 2 bits of information. It's got to be 250 meters from point A. So if we read the scale there, it says that 1 centimeter is equal to 100 meters. So this is going to be between 2 and 3 centimeters. It's going to be 2.5. Again, you could divide 250 meters by 100, and that would give you the 2.5 centimeters that it has to be from point A. So if we start by drawing that, we're going to get our compass again, put it at the bottom of our ruler, measure out 2.5 centimeters. And then we're going to draw a nice circle around A, and that will show us all of the points that are within that 250 meters. So if we put it around that point, draw a nice circle around A, now we know all of the positions there that are 250 meters from point A. So it has to be somewhere within this circle, or on the outskirt of the circle on the circumference, and that all of those points around that circle are 250 meters from A. So for the second piece of information, it says that point T is equidistant from points B and C. So to get it to be equal distances from points B and C, we're going to have to draw a perpendicular bisector of B and C. So we're just going to have to join them up to form the line which we could call BC, and now we're going to want to draw a perpendicular bisector. So again, we'll get our compass, we'll put it on point C, we'll extend it past halfway, and we're going to draw a nice arc all the way round, and then we're going to move that onto point B without changing the size of the compass, and again drawing a nice arc there so that we can draw our perpendicular bisector. So we can move all of this out of the way, and now we're going to want to draw our line. So again, if I start on the right hand side so that I can extend it over past the circle, then you can see that there are 2 points where it crosses the circumference of the circle. So we want to obviously only label one of those points. As it says, show one of the possible positions for T, and those 2 positions where our perpendicular bisector intersects the circle are both of our points. So obviously we would only mark one of these, but if we mark them both, we could choose either this position here, or we could choose this position here. Of course, being very careful because it does say to mark one of the possible positions. So we would only mark one of those, and that would be the answer to this question. Okay, so looking at a probability problem. It says that there are 9 green beads and 11 blue beads in a box. Jim adds 10 more beads to this box. He's going to take at random a bead from the now 30 beads in the box, and the probability that he will take a green bead is 2/5. How many green beads did Jim add to the box? Well, if he adds more beads into the box, and now it's out of 30, well, what would this fraction be out of 30? So let's figure that out. Well, if we want 30 on the bottom, we'd have to multiply the 5 by 6. And we'd do the same to the top. So 2 times 6 would equal 12. So out of the 30 beads, there must be 12 green beads. And pretty much that has already solved the problem just by turning that denominator into the new amount of beads in this box. So if we look at this, we've currently got 9 green beads. We know that it has to go to 12. So we must have added 3 additional green beads into the box. Okay, so we'll just double check our thought process there. So it's out of 30, our probability was out of 5. So to make that out of 30, we've multiplied by 6. So the numerator goes to 12. There were 9 green beads. That's gone up to 12. So that's an extra 3 beads. So 3 green beads. Okay. And there we go. There are obviously other ways of working that out as well. Like you could add an amount, basically trial and error. You could add 1 bead in, 1 green bead in, see if that simplifies down to 2/5 if the rest were blue. If that doesn't work, add 2 green beads in, add the rest to blue, see if it simplifies. But I think this was definitely the fastest way here, just looking at that denominator, making sure it matched how many beads were going to be in the box in total. So there we go, there's a little probability problem. Now you obviously need to be aware of how to use Venn diagrams as well when we are looking at inputting numbers from a given set of lists, and I'll link that in the description for you to check out as well. But in this one we're going to have a look at these more problem solving style based questions. So the one that you can see on the screen, we're going to have a little read through. It says 50 students were asked if they have a cat or a dog. 22 have a cat, 18 have a dog, 8 have both a cat and a dog. Use this information to complete the Venn diagram. Now sometimes you'll be given a Venn diagram, sometimes you'll have to draw it for yourself. For the purpose of these videos I've put them all in, but just be aware that you could have to draw them. So obviously if we have a Venn diagram we need to label it up to start with. Now this question mentions cat first, so I'm going to put the right as the other one and the left one as the one that's mentioned first. So I'm going to put cat here and I'm going to put dog over there. Again, it doesn't matter what order you put it in, just make sure that it's clearly labelled. So looking at this question, it first says to us that 22 have a cat. Now the problem with a Venn diagram is we can't just put 22 in this cat section because there are some people that also have a dog, so some of them are going to have to go in there. So don't just put the first number in straight away, instead let's read through the entire question and see what information we have been given that could be put straight in. So it then says that 18 have a dog. Again, we can't put that straight in. If it did want us to put it straight in, it would say only before the word dog. So it would say 18 people have only a dog. But there we go, we can't put that in. So moving on to the next bit, it says 8 have both a cat and a dog. So that bit of information can go in because we know that 8 that have a cat and a dog would have to go into the centre. So straight away in the middle, we can put that 8 have both. It doesn't tell us how many have neither, so that is the unknown piece of information we're going to have to work out. Now we can move back to that first line as it says that 22 have a cat. Now you can already see that part of those 22 over here, we've got 8 that will have a cat and a dog, but those 8 people are included in the 22 people that have a cat. So to work out how many people have only a cat, we would have to take away the 8 in the middle from the 22. So do your working out to the side, I would write 22 take away 8, and that is going to give us a total of 14 that have a cat. And now you can check because these two numbers should add up to 22. So 14 and 8, do they add up to 22? The answer is yes, so we've got that correct. We can then move on to the 18 that have a dog. Now of course we've still got the 8 in the middle, so we would take away the 8 in the middle that have both away from the 18, and that leaves us with a total of 10. So 10 people have only a dog. And now we've got quite a lot of information there, but we need to figure out what goes on the outside. Now if we add all of those up, so 14 plus the 8 plus the 10, that adds up to 32. So we have 32 people. Yeah, it does add up to 32, yeah. We've got 32 people, so we need to figure out what goes on the outside. So at the moment we've got 32. To make that up to 50, we would have an additional 18 people that would go on the outside that have neither a cat nor a dog. Okay, so that's one type of question that you can have where we've been told what goes in the middle in the crossover section, in the intersection. So let's have a look at one that's slightly different. And to be honest, before we start, we need to just have a look at this little symbol here. This just means the universal set. It just means all the numbers that are going to go inside this Venn diagram somewhere in there. And in that, it says all the odd numbers less than 30. So it might just give you the list of numbers. If it doesn't, it's probably best just to write them all out. And there's quite a lot of odd numbers between 1 and 30, less than 30. So I'm not going to write them all out, but you could just go ahead and write them all out. 1, 3, in fact, let's just write them out. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, and the rest. Now these are all the numbers that are going to go in the Venn diagram, and they're only going to go in there once. Okay, so there's not going to be any repeats of these numbers, but they are all going to go in the Venn diagram. Now it says set A has got these numbers and set B has got these numbers. Now if it doesn't label the circles in the Venn diagram, just label them yourself. So we'll call this A and this one B. So having a look, now the first thing we want to identify is what can go in the crossover, the intersection there. So if we have a look in A and B, there is a 5 in both. So let's cross off the 5 and let's put that into the Venn diagram. And I'm also going to cross that off my main list up here as well, cross that off, so we're not going to put it in twice. Let's have a look, there's also 15 in both, so let's cross that off and we'll put that in the middle as well. And then we'll cross that off the main list. So these are all the numbers that we've got left to put in a Venn diagram. There's none that are in A and B anymore, so all those numbers are in set A. I'm just going to put them in the A circle, so 9, 17, 21 and 29. We'll cross those all off and cross them off the main list, so 9, 17, 21 and 29. There we go, they're gone. And then 25 in B as well, so we'll put that one in there. Again, crossing it off both lists. So in terms of the numbers we have left, we've got the 1, we've got the 3, and I'm not going to circle them all, I'm just going to start putting them in because the others are crossed off. We've got 7, 11, 13, 19, 23 and 27, there we go, and that is our completed Venn diagram. Now it could be asked any sort of question on probability here, but I've put a little selection in down the bottom. It says a number is chosen at random, find the probability that is in set, and then we've got 3 questions to have a look at. So we've got 2 symbols that we need to know here. We've got the U, which is the union, and there we go, the union, we'll talk about that in a sec, and we've got the N, which is the intersection. There we go. And these little symbols can be replaced with some words if it helps. So the U for union, I replace with the word or, and the N for the intersection, I replace with the word and. And I quite like replacing it with the word and because the middle letter in and is N. So I always tend to remember that the intersection there, the N is and. So let's have a look. The first one is U. So we've got A or B. So the numbers that are in A or B. And it is a probability, so we'll talk about writing it as a probability in a sec. But if we have a look at the numbers that are in A or B, well, we've got the 9, the 17, the 21, the 29, which is in A. We've got the 25, which is in B. And then we've also got the 5 and the 15, which is in A and B. So just because that's in both doesn't mean it's not in A or B. So in fact, finding the numbers that are in A or B is all of these numbers within the Venn diagram, okay? So they are all the numbers that are within the
the Venn diagram there. And if we count them up, there's 1, 2, 3, 4, 5, 6, 7 numbers there. I'm going to get rid of that highlighter there, but we've got 7 numbers. So let's write that down. We've got 7 numbers that are in A or B out of a total. And again, you can count them all from the Venn diagram or from that list that I did at the top, but all the odd numbers between 1 and 30. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. There you go. So it's 7 out of 15. So that word union, if you think about that as like the United Kingdom, the union is the collection of all the countries there, and it's the same for the Venn diagram. It's the collection of everything within that sort of that land there. If you kind of imagine it like a country, you've got the collection of all the numbers. So you've got 7 over 15, and that is the union of A and B. Now if we have a look at the next one, so B, we've got A, N, B, or the intersection of A and B, which again can be replaced with the word and. So the numbers that are in A and B, well, there are only those 2 numbers there that are in both A and B, the 5 and the 15. So that there is the intersection, the numbers that are in A and B. And if we write down the probability of that, that's 2 numbers out of, again, 15 numbers. There you go, so there's our 2 options there for the union or the intersection. I've also included this extra one here as well for C, which is A dash. Now if there's a dash with a letter, it means not in A. So all that little dash means is any of the numbers that are not in A. Now if you have a look at the numbers that are not in A, well, we've got the 25, which is in B, that's not in A. We've got all these numbers around the outside that are not in A, but none of the other numbers. So we've got the numbers which are just in A, the 9, the 17, the 21, the 29, and we've also got the numbers that are in A and B, the 5 and the 15, but they are also in A, so we can't have those ones. So we're just looking at the numbers that are in B and the numbers on the outside. So we've got 1 number in B, and 1, 2, 3, 4, 5, 6, 7, 8 numbers there in green around the outside. 8 plus 1 is 9, so there are 9 numbers that are not in A, and again that's out of 15, writing it as a probability. So it says some people went on an activity course and each student had to choose one activity from art, drama or music, and then it starts to give us all this information that I'm going to read through in a little bit. It says one of the students is chosen at random, write down the probability that it is a boy that chose music, and we'll discuss that a little bit more at the end. Now when it comes to this sort of question here, and I said already we're going to have a look at two-way tables, we need to get this information organised, okay? There's so much writing there, there's so much going on, and a two-way table in this circumstance here is going to make this a lot more, well, add a lot more clarity to this question. So if we have a look, okay, it says that they choose from art, drama or music, and then later on it goes to talk about whether they are boys or girls and what they chose. So when it comes to this type of question, all we need to do is draw a little table. I'm going to try to draw one as best as I can here. There we go. So I'm going to have a few rows there so that I can have boys, which I'm just going to label as B, girls, which I can label as G, and I'm going to put a total down here as well. There we go. And then obviously they chose from 3 different activities. So we've got art, which I'll put first, we've got drama, there we go, and we've got music. There we are. So there are my columns. Okay, so start putting this information in, and again, I'm going to put a total column at the end there. Right, there we go, just extend that a little bit. Right, okay, so we can start putting all these pieces in the right boxes, okay, and obviously your table is just a way of organising it, so you don't have to worry about whether you put the boys and girls down the left or whether you put art, drama and music down the left there. Okay, you can organise it however you like. But we've got 41 students in total, it says, so I'm just going to go through this line by line and see what I can put in. So there are 41 students, so we'll stick that in, that's 41 in total of the boys and girls in the bottom right there. It says 15 of the students chose music, so that's the total, that's not necessarily boys or girls, it's just 15 of the students that chose music, so 15 down here. Then we have 30 students were girls, okay, so we've got that's 30 in total that were girls, there we go, 30. The next one, we've got 8 of the girls chose art, so in the art column, 8 of the girls chose art, so let's have a look, that's 8 girls there. Then we've got no boys chose art as our next line there, so no boys chose art, so I'm not going to leave that blank, I'm going to put 0 in there. And then it says equal number of boys and girls chose drama. Now we don't know how many chose drama just yet, so we'll have to come back to that one in a little bit. Right, okay, so if we start adding in some numbers then, so down that art column there, and essentially we need to find any columns or rows that have one gap in them. So that art one there stands out to me. There's 0 boys and 8 girls, and that's 8 in total. So that's 8 there. We've also got the total amount of boys. We know there's 41 people in total and 30 girls, so that's going to be 11 boys there.
And then we've got the bottom row as well. We've got a missing gap to the amount that did drama. So it's 8 and 15 here at the moment. In total, that is 23. And it's got to go all the way up to 41 to get the total at the end there. So that is an extra 7 to get to 30, plus the 11 is an extra 18. Right, there we go. So now we can actually go back to that last piece of information there. It says equal number of boys and girls chose drama, because now we know that there are 18 people that chose drama. So equal numbers, half that, 9 and 9. And then we can go about filling in those last two as well. On the top row for the boys, we've got 9 in there so far. We need to get a total of 11, so that's an extra 2. And then moving downwards, okay, if I look down for the last box here, it's got a total 15. So that's going to have to be 13. Now, as that's the last box that I did, one thing that I do want to check is that these still add up to 30 on the end there. So always double check the other way on the last box that you put in. So 8 and 9 makes 17. Add the 13 is 30. There we go. And that's just a little check for you, just saying that you know you've done it all correctly. But there we go. That is my two-way table drawn. I now just need to have a look at this question. So the question down the bottom says, one of the students is chosen. So one of the students is chosen. Okay, there we go. Write down the probability that it is a boy that chose music. Okay, so it's saying one of the students is chosen. So obviously there are 41 students, so it's out of 41. And it says what's the probability it's a boy that chose music? Well, if we have a look in our table, boys that chose music, there are 2 of them. So that means that the probability of picking a boy that chose music out of the 41 is 2 out of 41. Okay, and we're going to have a look at another question in a sec where the language is slightly different. But in this question, the language said one of the students is chosen. It didn't dictate that we were just picking from the boys or just picking from the girls. It just said one of the students. So as there were 41 in total, that's out of 41. And a boy that chose music, there are 2 of them, so 2 out of 41. So it says here there are 10 boys and 20 girls in a class, and the class has a test. It says the mean mark for all the class is 60 and the mean mark for the girls is 54. Work out the mean for the boys. So when it comes to a question like this, obviously we know, or hopefully we know, that when we're normally working out a mean, we get the total, we divide by how many people there are or how many things there are, and we get our mean. Okay, so we do the total and we divide by the amount, okay, for whatever it is. There we are, on its most basic sense there with the mean. You do the total divided by the amount. Well, in this question here, obviously it doesn't actually give us the total. It tells us what the mean is, it tells us the amount, it tells us that there are 10 boys and 20 girls, but it doesn't actually tell us the total. So what we're going to do is we're going to go backwards to work out some of these totals, okay? So we're going to think about this in reverse. All right, and that is how you get the mean there, the total divided by the amount. Okay, so if we link some of these things up, then it says that there are 10 boys. It doesn't give us the mean for the boys, so that's no good so far. So that first piece of information that we are actually given in terms of the mean, it says the mean mark for the whole class is 60. Well, if we were going to work out the mean for the whole class, we'd get their total. Let's call that X. We divide it by the amount, and in this case the whole class, well, there's 10 boys and 20 girls, so we would divide it by 30, and it would give us this mean here, which it says is 60. So in other words, we're looking for a number that divides by 30 that gives us the answer 60, and we can just do that in reverse. We can just do 60 times 30. So actually all we're going to do in these questions is we're going to link the mean that we're given with the amount that is appropriate for that mean. So I'm going to get rid of this little bit of algebra that I've drawn here, but obviously you could think of it in terms of an equation, but this is the sort of concept that we're going to run throughout this question, and hopefully once you actually get your head around this and why we multiply instead of divide, obviously we are doing a reverse. This question obviously becomes a lot easier then. Okay, so obviously thinking about this topic's actual name, it's called a reverse mean. Normally when you work out the mean, you do a divide, and obviously then the opposite or the reverse of dividing is multiplying, and in these questions we're going to be multiplying rather than dividing to go backwards. So let me get rid of that. So let's have a look. So obviously we've been given that the mean for the whole class is 60, and we've just established that there's 30 students or 30 people in the whole class. So we're going to do 60 times by those 30 students, and that's going to tell us their total. So 6 times 3 is 18, add on the 2 noughts, that's 1,800, and that is the total for the whole class. And it's usually worth just labelling these, particularly if you haven't quite got your head around it. Let's just label that total for class. There we go. Right, so the next bit of information then, we've also been told that the mean mark for the girls is 54. Now, in terms of the question, look, there are 20 girls. So if there's 20 girls and their mean is 54, we'll take their mean, 54, times it back by that 20 to find out what their total was. So 54 times 20, there we go, and that gives us 1,080. And there we go, there is the total for the girls. And let's just label that again. Total for girls.
Right, so just thinking logically about the information that we've got here, we've got a class of boys and girls. It says the total for the class is 1,800, the total for the girls is 1,080. So logically we can work out now the total for the boys, we can subtract those away from each other. So 1,800, take away 1,080, and let's write that down. There we go, take away 1080, leaves us with 720. There we go, and that's the total for the boys. Let's label that up, total for boys. And now we can go about answering the question, because now we know the total for the boys, we can actually think about working out their mean, and that's what the question wanted. It said work out the mean for the boys. So we've got the total for the boys is 720, and in total up here we were given in the question, let's highlight it in the same colour, there are 10 boys. So to work out the mean, just like normal, we would just finish this off by saying the total for the boys is 720. I'm going to divide that by how many boys there are, which is 10, and that gives us a mean of 72. There we go, and there's our final answer. I'm just thinking about what we did there, just working backwards through the question, multiplying the means by the amount to get the totals, and then using a bit of logic there to find out therefore what the total for the boys must have been, and then just working out the mean as normal.
Okay, so looking at an outlier. Now an outlier can kind of appear anywhere, but we tend to look at it when it comes up on scatter graphs. So it says here, Amy records the number of children visiting a local paddling pool each day. The information for one of these days is an outlier on the scatter graph. Now hopefully when you look at it, you can see which one the outlier is. It's one that lies outside of the usual trend of points. So if we look at this one, you can see that this point just here is outside of the usual all the usual points which would normally follow this kind of line of best fit that we could draw in just there. Obviously I've just drawn a little sketch in. So that is the point which is the outlier. So we could be asked a couple of things here. Could be asked to write the coordinate, highlight it, anything like that. If we're going to give the coordinate, we've got to be very careful, just read that very carefully. So that is 24, so if I write that over here, it'd be 24 on the x-axis. And if we go across, it doesn't land on a very nice number by the looks of things, 12.5. It's in between 10 and 15. So again, you've got to read that very carefully. So using a ruler and a pencil just to trace that across. But I'm happy with that, 24 and 12.5. So the other thing that we could be asked is to give a possible reason for this outlier. And when we're asked about this, we're trying to think about something logical. We're trying to think about something in real life. So we're not trying to come up with anything silly for this. So it says here, what's a possible reason? Well, let's have a look at the information. So why on a day where it was 24 degrees Celsius, were there a lot more children? You can see up here there's another point around 24 degrees, and on that day it's like 42.5, so an extra 30 children. So why are there 30 less children on this particular day, even though it's hot? So let's think about a real life scenario. When are the days where children are probably going to be going to the paddling pool? Probably at the weekend. So why might there be 30 less just here? Well, maybe it was a weekday. Okay, so that is a pretty logical explanation. There's lots that you can come up with, but just try and think about one that just sounds ridiculously logical. Okay, so give a possible reason. Okay, it was a weekday, not a weekend, something like that. It was a weekday, or you could say something like maybe it was raining. Okay, yeah, it's hot, but it could be raining as well. People probably aren't going to want to go out while it's raining. Okay, so lots of different things that you could think about there. The idea is, as long as it sounds reasonable, it's probably okay, but you're not trying to come up with anything silly or out of the box thinking here, just a real logical reason as to why that might happen. Okay, if you're still with me, congratulations, you've made it to the end of this revision session. There was a lot that we've just gone through there, a lot of topics, but hopefully at a nice slow pace. And hopefully as you were going through that, you have picked up some topics that maybe you might not have got tomorrow had we have not gone through it. So hopefully that was useful and helpful, and you have picked up some decent questions there that hopefully come up in this exam. Don't forget to leave me a comment and let me know how you get on, and genuinely I really do wish you the best of luck. You've got this, go and smash that exam. But otherwise I will see you on the next one.